চাপা পটাশ। হ্যাঁ নমস্কার।
হ্যাঁ, গুড মর্নিং স্যার।
গুড মর্নিং, ভালো আছেন তো?
হ্যাঁ হ্যাঁ, এই তো
বাসাও
অনলাইনে
ঠিক আছো?
দেখছি আপনাকে।
হ্যাঁ হ্যাঁ বিমলদা, হ্যাঁ বলুন। হ্যাঁ
বলছি যে ওই স্যার কাটিমনি ওই ফিল্মটা একটা পেন ড্রাইভে নিতে চেয়েছি। আমি বলছি যে এই যে খামে ঢুকিয়ে দিচ্ছি কি লিখবো, মানে অফিশিয়ালি কিছু
প্রেজেন্টেটিভ ডক্টর কাটিমনি মানে ওনার নাম। হ্যাঁ বিমলদা নমস্কার।
হ্যাঁ নমস্কার, সব ঠিক আছে?
ম্যাডাম নমস্কার। হ্যাঁ হ্যাঁ বিমলদা, আজকে আমাদের ন্যাক
আমি জানি
ন্যাক পিয়ার টিমের ভিজিট চলছে, ফলে আজকে অবস্থা মোটামুটি ভালো নয়।
হ্যাঁ খুব 5 মিনিট বলে চলে যাও।
হ্যাঁ অবস্থা ভালো নয়, মানে এমন চলছে প্রত্যেক সময়ে, মানে কন্টিনিউয়াস এই ঝামেলার মধ্যে আছি।
আমরা আজকাল সাজ পোশাক নিয়ে খুব কনসার্ন হয়ে গেছি।
হ্যাঁ
আমরা আজকাল সাজ পোশাক নিয়ে খুব কনসার্ন হয়ে গেছি।
হ্যাঁ
ন্যাক মানে তো সাজ পোশাক করা।
ও সাজ পোশাক, সাজ
সাজ পোশাক। হ্যাঁ
আমি শুনলাম শ্বাস প্রশ্বাস।
না সাজ পোশাক
কথাটা এই কোভিডের জন্য।
না না এই ন্যাক নিয়ে বলছি, আমরা সাজ পোশাক নিয়ে খুব কনসার্ন হয়ে গেছি।
হ্যাঁ হ্যাঁ এক্স্যাক্টলি আপনি একদম ঠিক বলেছেন, এবং আমিও ওটাতে অবাক হই যে কে কতখানি সাজলো তার উপরই তো নম্বর নির্ভর করে।
তাই দেখছি তো। তাহলে আমাদের ক্লাস নিয়ে কি লাভ? স্টুডেন্টদের বলি সেজে গুজে এসো, যে ভালো সাজবে তাকে বেশি নম্বর।
হ্যাঁ
পড়াশোনা করে কি লাভ?
হ্যাঁ
আগের দিনের মেয়ের বিয়ের মতো হয়ে গেছে।
হ্যাঁ পড়াশোনা করে লাভ নেই তো।
যতটা পারো সাজো।
মুশকিল হলো কন্যা দান তো হচ্ছে না, ওটা তো আমাদের কাছে থেকে যাচ্ছে। যদি ঝামেলাটা ওদের মাথার উপর চাপিয়ে দিতে পারতাম, আমি বলছি না কন্যারা ঝামেলা, কিন্তু মুশকিল হলো যদি অসুবিধাগুলো ওনাদের মাথার উপর চাপিয়ে দিতে পারতাম যে এবার আপনারা সলভ করে দিন, তাহলে তো ভালো হতো।
আমরা শুরু করে দিই। জয়েন করেছে তো, শুরু করে দাও।
ম্যাডাম আপনি আসছেন তো আজকে বিকেলে?
হ্যাঁ আমরা 4টেয় পৌঁছবো বলেছেন, আমি ওই 3টের মধ্যে ঢুকে যাব।
আরেকটু আগে আসুন ম্যাডাম, আরেকটু আগে আসুন।
3টেয় ঢুকে যাব।
হ্যাঁ চলে আসুন।
হ্যাঁ
আচ্ছা
চলে যাব।
আচ্ছা আমরা শুরু করব, তাহলে শুরু করে দিই নাকি?
হ্যাঁ
শুরু করে দাও। তারা আছে।
হ্যাঁ হ্যাঁ একদম, আমরা তো রেডি। জাস্ট দেখে নিলাম।
আপনি তাড়াতাড়ি শুরু করে দিন।
একদম। তো good morning everyone. So now we are going to start this webinar on cryptology, big data and cyber security. So this is actually the outreach program of Rsa Crypto Center. Acha shona jacche? I'm audible?
You are audible. Yeah, very good.
Okay. And this is outreach program of Rsa Crypto Center for Cryptology of ISI, and this program is organized by East Calcutta Girls College. Considering the importance of this big data actually in general, and this information security in every sphere of our life, today's life, we are so intended to spread this knowledge and discuss the possibilities of these applications with the students in some interactive manner. For this, we have a fantastic group of speakers today also, including Professor Dimal Kumar. So without wasting time, I invite Dr. Shukla Hazra, Principal of East Calcutta Girls College, to deliver her welcome address.
Good morning. I welcome first Dr. Bashod Chaudhary, Honorable Vice Chancellor of West Bengal State University, and Professor Dimal Kumar, Head of Rsa Crypto Center for Cryptology and Security, ISI. And this is the brainchild of Professor Dimal Kumar. And also today we will get Professor Shubham and Professor Pinakpani Pal from Indian Institute of Statistical ISI, India Statistical Institute, Mr. Kushal Sen, Microsoft Corporation, and Professor Abhishek Odhikari, Presidency University. And already Professor Jayanto Ghosh spoke about the topic, that is cryptology, big data, and cyber security. We know that it is very important in today's life for our own security, for and all the security of the institution, also big data for disaster management in a sphere. We and Professor Bimal Roy, who is also the chairperson of National Statistical Commission, Ministry of Statistics and Program Implementation, Government of India. He gives me the opportunity to organize such type of workshop, and we are organizing this workshop for last 3 years in association with ISI, and where professors directly teach the school students and also college students about cryptology. And today there is also they talk about the big data. And 2 years we arrange 6 to 7 workshops or seminar per year. But in 2020, due to pandemic situation, it goes down because it was tough time. Now we are arranging these workshop online. So I must say that COVID-19, though it is a curse to the whole world, but we learn a lot from this. We learn how to accommodate the new system and new technology in teaching and learning also. There may be I hope that there may be a change in teaching and learning process, because as a principal of a general degree college, I have the my experience that few students who could not attend class daily for distances, they are attending the classes online. So now the thing is, we are talking about the hybrid system. Sometimes they may physically present in the class, and sometimes they may attend online. Like this, in this today's seminar, students from Constitutes College, Jadavpur University, and also students from NIT Durgapur, IIT Kharagpur, IIT Kanpur, and other colleges, many colleges, students are attending this seminar. We cannot ask them to come daily to this physically sometimes, but it is possible only for online workshop. When I arranged a map quiz for online, I have seen that students from remote villages, they attend the map quiz. They never thought of coming to Calcutta, and they are getting chances. So this is the good side of the COVID-19, and we will change to that. And I must welcome again all participants, all resource persons, honorable resource persons to this workshop, and also again thank Professor Bimal Roy to give me this opportunity, and also Professor Bashop Chaudhary, who also gives me this opportunity to organize this seminar and workshop on behalf of East Calcutta Girls College, all staff members. I thank you all. Thank you everybody.
Thank you. Thank you, madam, for your such a warm address. And it's always a matter of great pleasure to us having Professor Bashop Chaudhary, Vice Chancellor, West Bengal State University, in this program. And today, particularly in spite of his very busy schedule, as NAC committee is visiting his university yesterday, today, and tomorrow, he has kindly joined us for a very brief period. So we are really thankful to him and waiting for his very impressive lecture. So I invite Professor Chaudhary for his brief inaugural speech.
Jayantabu, could I start?
Yes, sure.
Jayantabu, could I start?
Sure.
Okay, with
am I not audible?
permission, with permission from all of you, with permission from all of you, respected Professor Bimal Roy, respected Principal of the East Calcutta Girls College, Dr. Shukla Hajra, and my dear colleagues, Shubhamoy, Pinakpani from the Indian Statistical Institute, Jayanto Babu, the person coming from Microsoft, Dr. Abhishek Odhikari, Professor Abhishek Odhikari, and all others who are present over here, and the participants. Indeed, it is a very busy day for all of us. From yesterday 7 o'clock to 9 o'clock or 9:30, it continued. The NAG visit in my university, and today also the NAG visit has started, and we are all in the university, and from time to time I am being called to clarify some of the points that are being raised by the NAC committee. So for the first time in the first cycle, we are doing this exercise, and let's see what goes, what comes out of this exercise. Anyway, the seminar or the webinar that is being organized today, that is on cryptology, cybersecurity, and big data, or cryptology, big data, and cybersecurity. And the whole initiative behind this program has been taken by Professor Bimal Roy. He wanted the students of schools and colleges to understand what lies in future in terms of mathematics, in terms of statistics, in terms of big data, and in terms of cybersecurity. All of you know that all these are emerging areas, and in emerging areas, it is necessary to visualize what will happen. It is necessary to also orient oneself towards taking a career as one grows up. So that is the kind of idea with which this webinar or the webinars are being organized. Behind this whole exercise, Professor Bimal Roy played a very, very important role, and he basically got some funds from the Department of Science and Technology or Department of Statistics, and wanted to create an awareness in students about the future scenario, about the subjects that are emerging. So that is what I just wanted to I'm getting message and getting distracted. So getting message and getting distracted. WhatsApp messages are coming with so point is, all of you know the big data, a large number of data. All of you know the kind of data that is being generated in Hadron Collider. Hadron Collider, every second, every millisecond, the particles are being formed and particles are being destroyed, and huge quantity of data are being produced, and it is necessary to discern which data will be important and which data will not be important, which will be statistically significant, which will not be statistically significant, which will throw up some light about the structure of the universe and the birth of the universe, and which will not be that important. So the point is, this discerning this data and the mechanism, all these are important, and they are all jobs of mathematicians and statisticians who work in this area of big data. All of you know about cybersecurity because everything is going on now. Particularly in this COVID situation, we know that all of us are working on internet, and all of us are working on systems. Now, when we are working on computer systems, what really happens is the information that is being sent. Very simple example will be a false email coming from one source to the other, one source to a sink, coming from one source to me. How do I know whether it is a correct mail or not? A large number of data. Someone is saying that put your income tax, assess what is called the PAN, and you will, this much amount will be credited in your account. Now this is a false email. We immediately know, because it is, in terms of money it is important, but the point is, you come here, we will have a cup of tea together. That is something, that is also a false email, but I will not be able to discern whether it is a false email or not. How do I know? So these are some of the things, a large data, large question of security. You are maintaining your defense system in the country, you are maintaining your finance system of the country, you are maintaining your
Hello.
confidential system of the country, and all these are being maintained on computers. All these are being maintained on clouds, and no one can enter into the cloud without the password and the security system. And how do you create that kind of security system? And Professor Dimal Kumar is the best person to say. He always tells about the key of the locker, and now it is something like DigiLocker that the UGC is saying, where the digital mark sheets and certificates will be kept, and then there will be academic bank of credit that also will be maintained on the cloud or on computer system. So all these, how are they really made? The virtual world, the real world that we are seeing, that we are going by bus, or we are going by auto, or we are going by auto rickshaw, or we are going by car or something, and the real world is emerging, and we see the real world. But the virtual world, how does it look like, and how do you work? So that is something that will be talked about in this particular seminar, or in this particular webinar. The East Calcutta Girls College and the principal took initiative to work as the person in charge to disseminate this information. Information flow is not, does not happen from source to sink directly. Information goes from one sector to other, and then it does. For example, if you see the hierarchy, from the prime minister, information does not come directly to the lowest possible level, unless he directly addresses them. From the chief minister, honorable chief minister, it does not come directly to the masses. It will come gradually from officer to officer. So similarly, for the cyber security, or for the data to flow, information to flow, information will also flow in a particular way, and correct information will be screened, bad information will be thrown out, and in this manner we will process. How are those things done? How will that structure be built up? How will we know that this is a data that is to be banked upon, and this is a data that is to be thrown away? So these are some of the points that needs to be talked about. And I think that the best possible speakers of the Indian Statistical Institute, the Microsoft, and the Presidency University, they will be here to talk about the importance of the subject, and I am sure that it will create a lot of impact on your mind. So I will not elongate my speech. I will end here by saying all good wishes to all of you. Thank you very much for giving me the opportunity, and I wish all of you well. I thank Professor Bimal Roy, all the other speakers, Professor Dr. Shukla Hajra, Dr. Jayanta Ghosh, who has been tirelessly working, for a long time, years together, to inform and create awareness in students. So I thank all of them for giving me this opportunity, and because of the necessity of this, my own involvement in this NAC process, I will request your permission to go out of this meeting, and I wish you all well. Thank you very much.
Thank you, Professor Chaudhary, for your beautiful and this enlightening address. Thank you very much. Now we are entering in our main program. The first talk will be delivered by Professor Dimal Kumar, and he's quite, already you have heard about him, and Professor, already Professor Roy is one of the pioneer in this field of cryptology, and he is the key person to establish a center for excellence to study this information security in Eastern India, that is ISI Center for Cryptology and Security in ISI. Being a renowned statistician of our time. Professor Rai served as the director of Indian Statistical Institute, and at present he is chairman of National Statistical Commission. For his contribution towards education, Government of India honored him by conferring Padma Shri Award. So now I request Professor Rai to deliver his talk.
Okay, good morning. So shall I speak in Bengali or English? One of the
Maybe in English because
participants might
so
help.
many outsiders are,
Oh, is it? Okay, then I
maybe
thought.
in English.
Okay, then maybe let me start with English. This time I
Because
finally got my colleague. Yeah. Okay, I'm continuing. So this time, since I got my colleague Shubham Mitra to speak, so I leave it him to introduce the subject cryptography. Instead, I'll talk something else which is relevant to both big data and cryptology. So I'll tell you two stories, and you have to think about the two stories for a couple of days. So what I meant. So the first story goes about. This is about Sir Ronald Fisher, who is considered to be the father of modern statistics. He was a professor at Cambridge, and this incident will be eye-opener to many of us, and this is very deep, even though it's a story. So, this the habit of drinking tea, and that I'm now drinking tea, came to India with the British. We had no system of drinking tea. The British got tea to India, and the British style of drinking tea was you mix with milk and as well as sugar. So now it's only last 20-25 years all these things started, like with sugar, without sugar, with milk, without milk, and so on and so forth. But the traditional British style was, if a guest comes to your house, you offer a cup of tea prepared with milk and sugar and a few cookies, what you call biscuits. So one day Sir Fisher went to his friend's house, and his friend's wife offered him a cup of tea as usual, the British style, and some cookies. And then suddenly a question came to his mind. All this great people have a very different way of thinking, different mindset. Something pops up into their mind, and that creates, I think, a history in science. So he asked his friend's wife, "Madam, how did you prepare the tea?" Now let me talk about how do the British prepare tea. They will boil water. They will have a pot where they'll put the tea leaves. And then, after the water is completely boiled, so they'll pour the water on the tea leaves and allow it to brew it for a few minutes. Now the option. Now some of them also put sugar while brewing, expecting the sugar will be a good mix. It will mix well. But some of them do not put sugar while brewing. So after a few minutes of brewing, it is filtered, and milk is added, and sugar is added if sugar was not added while brewing. So there are two methods. There are two methods. One is where, see, water is boiled, the tea leaves are brewed. That's common. Milk is added at the end. That's also common. But when do we add the sugar? While brewing or after filtering? That is the two different procedure. So he asked, Madam, how did you prepare your tea? Did you add sugar while brewing, or did you add sugar after filtering? And the madam said, "Oh, I always add sugar after filtering." Then Sir Fisher asked her, is there any particular reason for this? She said, "Of course, because if you put the sugar while brewing, the tea tastes horrible." And then Sir Fisher asked her, "Can you really distinguish by taking drinking a few sips of the tea, whether the sugar was added while brewing or after filtering?" So of course, the one, if it is prepared by adding sugar after filtering, it will taste good. And if sugar was added while brewing, it will taste horrible. It's very easy to distinguish. Is that your belief? Or you think this is the truth? You know yourself very well. So of course, this is not my belief. This is perfectly true for myself. Okay. So here is a question or a concept is defined here. Is it belief or is it truth? Okay. Now, we normally start with a belief. No matter what is the background or the domain or the scenario, people do have their beliefs. Okay. And this is what we call hypothesis. Okay. But now, if you're a scientist, we just don't accept beliefs as truth. So we have to have certain additional analysis of this belief, maybe with the help of some data and some procedures followed, at the end of which you can say, yes, the belief is vetted, the belief is okay. Else I would say it's only a belief, the belief is not validated, so the belief is probably not right. So this is a scientific way of telling that. Now how do we come to this kind of conclusion? Start with belief. In this case, we start with the belief that madam can distinguish the two kinds of teas prepared. Sugar added after filter or sugar added while filtering, while brewing. So, Sir Fisher tells sir that you please play a game with me. So you bring me 2 pots of tea, 1 pot of tea prepared, putting sugar while brewing, and 1 pot of tea you add sugar after filtering. So she gets 1 pot here, sugar was added while brewing, another pot after filtering, sugar was added. So Sir Fisher puts it on the table on these 2 corners. Okay, left hand side type 1, right hand side type 2. Then he says, madam, you get me 10 cups. So she gets 10 cups. Below 5 cups, Sir Fisher writes 1, 1, 1, 1, 1 and puts it on the left hand side. And below the other 5 cups, he writes 2, 2, 2, 2, 2 and puts it on the right side. And then he pours tea from the first pot, the type 1 kind, into the cups below which we have written 1. And on the right side is another 5 cups. So he pours tea from the other pot where the tea was made using procedure 2. And now say, madam, you just take away the 2 pots. Now 5 cups type 1, 5 cups type 2. And then what he does, he kind of makes movement of the cup around the table and what we call randomize. He randomizes so that now she doesn't know which cup is from method 1, which cup is from method 2. It's all completely mixed. Then he says, okay, madam, you take 1 cup at a time, take a few sips and tell me this is good or this is horrible. That means method 1 or method 2. And she said, this is a very trivial thing. I'll just take 1 sip and immediately I'll be telling it correctly. So I'll tell all the 10 correctly. He said, okay. That's your belief. So let's try to play the game to validate your belief. So okay, then since we do statistics, we assume that people can do some error. So I allow you some error. Now then he asked, even if anyone has no capability of distinguishing between these 2 varieties of tea, how many one can tell correctly? Okay, answer is very simple. So this is where I actually lag this physical interaction. Normally I want my audience to answer this question, but here this is a little complicated, so I have to answer the question. So this will be 5. See, on one hand you just say all of them are of type 1. Okay, then this will be 5 of them will be correct. Even if we say randomly, we have no power to distinguish say randomly, then also this is going to be 5 correct randomly, hopefully. Okay, so this one gives no information, telling 5 correctly about your capability of distinguishing these two varieties of tea. So what you do, now you may do some mistakes, so I allow that. If you tell even 9 correctly, that means you do 1 mistake, okay, or maybe 2 mistakes, okay, I will assume that your belief is true. But if you do more than 2 mistakes, then you have to accept that it is only your belief. You have no valid reason behind your belief. Okay, so the game is played, and the lady tells that is 6 or 7 correctly. Okay, and this means is that it's only a belief, and she accepts that it's only a belief. She doesn't really distinguish between these two kinds of things. Now, what is the implication of this story? The entire development of statistics, even now big data, machine learning, all this things started. I think the root is in this story. So what we have, we start with some belief, okay, and then we have to find some data. So this is also, we have to generate data, or we have to look for data and relevant data by which we can possibly validate this belief or reject the belief. So need of data, right kind of data. So here the right kind of data was generated by Sir Fisher. By this game or by this experiment, he has generated the data. What is the data? He has created the experiment and then the response of the lady after testing each cup. So that is the generation of data. So you would do an experiment, generate data. If you are doing physics, chemistry, biology, or if you are in public, it could be on public data. So pertinent to a belief, you have to know what is relevant data which you are going to use for accepting or rejecting your belief. So then there must be methodology of this validating. So yes, methodology was that she will drink this cup of tea and will tell yes and no, and then depending on the number of right answers she gives, and we decide the threshold. And what is the meaning of this threshold? Meaning of threshold is that beyond the threshold, our belief is going to be true. Below the threshold, our belief is going to be wrong. So we have to set up this threshold. And when you set up the threshold, you also think of the error probabilities. So depending on how much error we are going to allow, since we believe that everybody is going to some error, so what we do, we actually decide a threshold. And this is also part of methodology, a rule of inference. And with the threshold of the experiment, at the end of the day, you either accept or reject your belief. Now, this entire process was not there before this particular story. And now you would see in every sphere of life, probably, maybe even in business domain, maybe in the security domain, you would see that you would start with certain belief. This is good, this is bad, this is not so good. Something like that. And then something like there is a belief at this point of time that demonetization helped India become digital. So that's the belief. So actually Reserve Bank of India is making a detailed study to validate or reject this hypothesis. So meaning that we have to see how do we study this one. You know, there was a demonetization happened, and then we have to see, first look for what kind of data. So what is the hypothesis here? The demonetization helped India becoming more digital. Okay, so we have to design this entire game. We have to see what is relevant data and how do we handle this data, what do we analyze, how do we make a rule of inference, by which at the end of the day, we should be able to say, yes, it helped in making India digital, or we may say that it didn't quite help India become digital. Some digital progress, but not really significant digital progress. So this kind of things are very pertinent, and the root of all this methodology lied in this particular story. Okay, this is my story number 1. And the second story, I think since Shubham will introduce cryptology, but I'll tell the story which will help you understand what he talks later on. So this goes to my high school days. And in my high school, we used to have every monthly test for each subject. And we write the test, the teacher will write down our names and put the scores against our names. Okay, and then sign it, fold it, put it in an envelope, seal it with a gum, and then gives our peon, take it to the headmaster. And the peon takes it to the headmaster. And then one day our math teacher told, is it very safe? And we understand what is meant by this is not being safe. So, you know, opening these envelopes are very easy. The helper, the peon makes tea for the teachers. There is some small office room, and there will be electric heater and a kettle of water which will boil and the steam comes out. And he said, if you hold this sealed portion of the envelope before the steam, the gum will loosen. Okay, and envelope will open. You can take that piece of paper where our scores are written out, and you can change the scores, and then you can seal it with the gum, and the peon will give it to the headmaster. So the scores that you are finally getting is assigned by the peon, not by me. And then what is the remedy? So he said, I have thought of a remedy. And what the remedy is, you know, asked to know what are Atachi cases. You know, I don't see many Atachi cases these days. In our time, Atachi cases were very popular. These are, you know, small, very hard boxes, and they'll have two locks at the two ends. And there are two keys. One key will open the right-hand side box, and the other key will open the left-hand side box. And unless you open both the sides, the Atachi cannot be open. And in our time, Atachi case was so popular. I remember in my wedding, I received maybe 6 or 7 Atachi cases. So this was that popular. So what we she said, I use an Atachi case, but very small size. I'm only going to send a piece of paper to the headmaster. I don't need to put my clothes and papers, etc. Just one paper. So I get a very small Atachi case. But the property remains same. It's a hard box, difficult to break. And then there are 2 locks at 2 ends and 2 keys. You have to open both of them to open this Atachi case. So then he said, okay, one key I'll keep with me, and the other key I leave it with the headmaster. Headmaster is the other key. So what he does, he says, I'll put the score sheet inside the Atachi case and lock my side with my key. And then ask the peon, now take it to the headmaster. Now the peon cannot open it. No steam coming out of this boiling water in the kettle is going to open this one. This is hard one. Presumably this can be broken so easily. So this is safer. But when you take it to the headmaster cannot open because headmaster doesn't have the key to this one. Headmaster cannot open it. So what headmaster will do? He will put the key, his key, to his side of the lock. So on the other side there is a lock. I don't have the key, only headmaster has the key. So headmaster is going to lock that side. So now it's both the sides locked. And then we will say the peon, now we take it to the teacher. So the peon gets it back to the teacher. And what the teacher does, he has the key for his lock. So he is going to open that lock. Still the other side locked. And then he tells the peon, you take it to the headmaster again. And the headmaster with his key opens this one. Okay. And the headmaster gets a piece of paper. Now what has been achieved in this example? Number one, using this hard metal body or some other synthetic material body Atachi case, you are making it's difficult for somebody to break this one. For the other case, that steam was loosening the gum and you could open the. But here you are making that difficult. for the person who is trying to get access to that paper. Okay, two other things I achieved this way. So I know for sure the headmaster and only the headmaster can really open this attache and get access to this piece of paper in my mark sheet. And also the headmaster is assured that it has been sent by this particular teacher, nobody else. So this is what I call authentication. So the sender authenticates the receiver, so nobody else can receive except the person who is meant to receive it. The receiver authenticates the sender because the receiver knows it has come from this sender and from nobody else. So these two authentications are actually materialized here. And this, in a sense, in a later part, which is now called public cryptography, which is the key of one of this communication these days. I think probably Shubham will talk about that. And I'll probably end with a third story of mine, relating. You can think of how to relate this one. So this is something like when let me tell you the story, and then I'll tell you how to use this one. I have two nieces. I do have two nieces. They're almost similar age. One is from one is Bhagni, my sister's daughter. One is my brother's daughter, Aiji. They're almost the same age. And if I have to get a gift for one niece, I have to get the identical gift from the for the other niece. So every time I need to give them some gift, I have to get two identical objects. Okay, now I'm blind. We assume that I'm blind. I cannot see. So I trust maybe Professor Hajra. I told Dr. Hajra, please get me two identical pens. Okay, and she gets it, and I trust her. So she says, I know that you trust me, but still, I want to prove to you that I have got two identical pens for your two nieces. So she wants to prove to me that she has got two identical pens, and I cannot see. If I could see, there is no issue. I can see and find out, but I cannot see. So she tells, okay, let's play a game. I'll design a game, and maybe she trusts Bashab, our Vice Chancellor, Bashab Chaudhary. Now let Bashab Chaudhary and you play a game. What is the game? She says, you take the two pens in your two hands. Just let me see. So I hope you can see, and someone can tell me, at least unmute and tell me, are these two pens identical? Someone unmute and tell me.
No, sir.
No, right. So Dr. Haja tells me to take these two pens in two hands, take the hands at the back. Okay. And then you may interchange your two hands or you may not interchange your two hands. Okay. So it was like this. I take it at the back and I do something you cannot see, and I bring it and I ask, did I interchange my hands? Someone tell me. Did I interchange my hands?
Yes, sir.
Yes. Okay. Now remember this one, then again I take it to the back. Did I interchange my hands?
No, sir.
No, right. Did I interchange my hands?
Yes, sir.
Yes. Okay. Now these two are not identical. So you would be correct all the time. Right? But if these two identical?
Yes, sir.
Right? Now, tell me, did I interchange my hands?
No.
No.
You don't know. You don't know. They are identical. Whether I interchange my hands or not, it will remain the same. Isn't it? If they're identical, you won't know if I interchange my hands or not. Right? One of you answer.
Yes, sir, we can't say.
You can say, so you have to guess. So, Madam Hajra tells me, let Bashab Babu and you play the game. And if Bashab Babu tells, say maybe there are 10 times. And if Bashab Babu tells all the 10 times correctly, then these two pens are not identical. Isn't it?
Yes, sir. Yes, sir.
And if he does the mistake even once, okay, then we know that these two pens are identical. Right? So Madam Hajra is proving to me through this game that these two pens are identical or not identical. Okay, even though I am blind. This is what is called, you will know later on, what is called zero knowledge proofs. Zero knowledge proofs. And this, what we are trying to use in reality, when you go for voting in a voting booth. And how do you prove that you are the same person, the polling officer? You show your voter ID card. Okay? And what the polling officer does, looks at the voter ID card, looks at your photo. And they have also a printout of the same photo in their list. So the polling officer will verify all the three: your voter ID card, the voter ID card copy in their record, and your physical appearance. And the voter ID card is going to, so they are going to, and also they'll probably ask you to put a signature. Now all these things are not good enough to stop forgery. Okay. So there will be notion of myself proving to the polling officer that this is myself and nobody else. Okay, so we are trying to use this kind of zero knowledge things for even elections. You are used to use OTPs, right? What are the OTPs? The bank want to prove, make sure that you are the right person and nobody else, isn't it? You have a mobile. So you are supposed to, okay, if I give a slap and take your mobile, that's a different thing. Assuming that your mobile is held with you, when the bank says OTP before any transaction is made, and if you can read the OTP and type it in, then the bank knows that it's me and nobody else. So this is also one way of what I call zero knowledge proof. You're proving your identity. So in this internet domain, identity is going to be an issue. And the way you prove your identity, there are many methods. One method is what I told this game. This is called zero knowledge proof. Okay, so let me stop here. To other speakers. So thank you all. And if you have any questions, Jayanto, you may share my email ID with all of them at the end of the webinar series, and you can send me emails. And you can trust me, I respond in 24 hours. Okay, Jayanto, over to you. Now Shubham is there, so. Jayanto.
Okay, thank you, Professor Rai, for your most valuable and insightful talk. The profoundness of your vision that will obviously enrich us. Thank you, sir.
Okay.
Now I invite Professor Shubham Moitro to deliver his talk. Professor Moitro is a professor of Indian Statistical Institute and obviously a top-notch cryptologist of our country. But in public domain, he is quite known face as regular in different TV news channels, as an expert in different social and political programs. His keen observation of these socio-political contemporary issues also reflected in his articles published regularly in different print medias, different newspapers, obviously, and also especially in famous Desh Patrika. Obviously, today he will enrich us obviously with his vision on cryptology and expert on cryptology. So, Shubham Babu. Shubham Babu, আপনি জয়েন
Yes.
করেছেন তো?
That's true. Okay. Okay, so this is purely a technical talk and nothing related to my other involvement in social issues. So this is absolutely a technical talk. So I think you can listen to me, right? Yeah, can anybody just unmute and tell whether you are listening to me? Is the sound going?
Yes, sir.
Okay. Okay, so I'm switching off the video because then the bandwidth will be properly utilized. So the issue is what we are discussing is we are discussing about cryptology, and I won't talk for a long time, but to give you some technical ideas. So I believe you are all from science background. So can you just quickly tell me a little bit that just tell me that which year and which department you are. Just unmute your mic and tell, maybe for 30 seconds.
The second year mathematics.
Second year?
Mathematics.
Okay, good. Then somebody else? Somebody else? Would you please respond? And
You, the participant, please respond.
so,
Just mention your
Second year ceramic. Second year ceramic department.
Okay. So what happens is actually, so this is some kind of test related to cryptology that most of you are actually just logged in and switched off your microphone and the video, and you should not listen. So this is the standard thing. I'm very convinced about that because I also do the same thing. So this is one random sampling that if you ask a simple question and you not get answer, and then you actually immediately know how many are actually listening just by a sample. Okay, but when there is a talk, we should actually think of a little bit of what I would say, that discussing about the technical things, and at least one or two, the probability that nobody is listening is really very low.
Second year mathematics.
Good. So we got 3 responses. That's good out of 26, right? 16. At this moment, there are 16 more to total 27 participants. We got 3 responses. So you understand that.
First
4.
year computer science.
Good. 4 responses. Then
First year general.
5, 6
Dimal
responses.
first year stat.
7 responses.
First year computer science.
8 responses. Good. Then I don't know. The 8 people are listening. That's enough. But now again, what you can do, you can just come out, and then what I have to do, then I have to sample. Okay. So the point is, when we are talking about cryptography, it is really related to several subjects. What are the subjects? The subjects are mathematics, physics, computer science, and any related subjects which have some scientific understanding. Now, what is a scientific understanding? Scientific understanding is to write down some logical statements like if, then, else, these kind of statements to come to a conclusion. Like I think many of you may remember that the sum of internal angles of a triangle is how much? 180.
180.
Right. So we must have some proof for that. And when we write down the proof, we take some initial assumptions, or we sometimes tell them postulates, and calculate we write down certain steps that this is parallel to this, these are the opposite angles, and all these things by which you prove that it is really 180 degree. So first of all, we need to prove certain things. So in cryptology, the idea is of proving something. So one important thing, since you are now in first year, second year, some of you might go into academics. So the main problem we are facing nowadays is actually proving certain statement. There are some statements in social issues, like today, how is the weather? It is little cloudy today. So you can, so how much sunshine is there? That kind of question, when you talk about a percentage and something, and there are many parameters, then it is sometimes very hard to actually get into certain exact value or telling about this happened. But still there is some scientific idea that it is more or less cloudy today in Kolkata. So that also have some scientific description. But if you tell that I toss a coin and the output will be always head, then these kinds of statements are actually absolutely wrong. So, and when we are proving something or we are making some corollary, we need to identify what we are proving, what we are actually trying to proving, because complicated expressions and all these things might be very hard to prove. So it is easier to find out issues where we can actually try to identify what we want to prove. The proof should be simple and it should be correct. So this is one part of learning anything related to cryptology, anything which has relation to cryptology related subjects. So the first thing I want to tell is when we are designing some software, like you log into this Google Meet software, so there are generally the things work very fast, right? So unless the things work very fast, if I want to log in and I have a computer and through Google Meet, if I need something like 15-20 minutes time to log in, then nobody would really like to log in. So we need to write down softwares or methods such that things can run quite fast. We do not need to wait much. In this direction, I like to introduce you a little bit about computational complexity. So can you just think of adding two 5-digit integers? Now, when you do add two 5-digit integers, how do you add those integers? You take the digits in the units place, you add them, and if there is a carry, you add that carry with the next 2 digits which are in the tens place, and this way you continue. So can anybody calculate how many additions will be required in this step, in this adding 5-digit numbers, 2 5-digit numbers? How many digit additions are required? Can anybody tell? Okay, for adding the units digit, how many additions will be required?
Sir, minimum 5 or maximum 9.
Right, very good. So maybe there would be 2 additions in each step other than the units place, and there would be 1 addition in each step. That would be the basic scenario. So we can simply say that we need to go for 2 into n many additions at most, which are digit additions, to add 2 n-digit numbers. Now, what is the largest integer that I can produce with an n-digit number? What is the largest integer? So, okay, 5-digit. What is the largest integer of 5 digits? Largest integer with 5 digits?
So 99,999.
So it is almost 10 to the power 5, right? It is in fact 10 to the power 5 minus 1. Is it clear? With 3 digits, I can create 999, which is 10 to the power 3 minus 1, right? So with n digits, what is the largest number I can create? 10 to the power n minus 1. Now, consider that when I am adding 2 n-digit numbers, the value of these numbers are 10 to the power of the number of digits. Now I am giving you another methodology for adding. Consider that you are adding 27 plus 36. But how you are adding? After 27, you are counting 36 many times, like 28, 29. That way you will go and count up to 36 times, and then you will get 63. So I think you understand that this method is absolutely not efficient. Is it clear? So we can add 2 numbers even if those numbers are very large, because we can do that very efficiently. That means if there is a number which is of the value v, then the number of operation to add two such numbers is actually log of v to the base 10. That is why we can add. Otherwise, we could never add two large numbers. This is called efficiency. Now come to multiplication. So if there are two n-digit numbers, how many digit multiplication and addition are required to get the result? Can anybody tell? I have two n-digit numbers. So the way we multiply, we take one digit, multiply with all the n digits of the upper number, write them down, the result, put a cross in the right hand side. Again, we multiply with the second number and do this way. And then after this digit multiplication, we go for some additions. So how many digit multiplications are required?
Sir, in factorial?
No. N digits into n digits. So n square many more or less multiplications.
Oh.
See, you take one.
Yes, sir.
Okay. So it is n square. Right. So that means this is another operation which is also very efficient. You will get the same efficiency when you like to divide, because division is actually some kind of multiplication. When you will divide, you will see that actually you are doing a multiplication. You just understand the division process carefully. Same thing is the greatest common divisor or highest common factor, which is known as, in Bengali it is told Goshagu, in English it is GCD or HCF. That how do we do GCD or HCF? Can anybody comment on that? If you know, how do we do this thing? Will anybody respond? Okay. So the way we did is we take one number, divide it by another number and take the remainder, and then we consider the remainder and the other number. We keep on dividing this, so the numbers become very small. And I give you an assignment, you do it, that how many steps are required at most when you calculate the GCD. You will find that it requires very less number of divisions. And already we told division needs the complexity or time something, the operation something like multiplication. So this is also a very efficient operation. Now, we can do all the computations not because of fast computer. We can do all these operations only because these operations, human beings or mathematicians or engineers or scientists, they could find out that there are algorithms, there are strategies so that we can do these things very fast. Now, if you have pen and paper, then you can try this experiment. You multiply 23 and 37. You will find that if you multiply 23 and 37, then finding the result will take at most 10-12 seconds. Even some good people can solve it in 1 or 2 seconds. But if you multiply 23 and 37 and do not tell your friend what you have multiplied and give him or her the result and ask him or her that, okay, can you factorize this for me? You will find that this becomes very complicated. This is actually the most interesting thing in these kinds of number theoretic algorithm. We learn these things from our childhood, say addition, subtraction, multiplication, GCD, and all these things. Sorry. So we learn these things from our childhood, and it is very natural that when we learn these things in primary schools, there is no requirement to understand why these are very efficient operations. But as we go in college level and as we are studying mostly mathematics and computer science related things, then it is very important to understand these things, that why multiplication, division, and all these things are very efficient, but factorization is not. Why GCD is very efficient, but factorization is not. Because anybody will ask, okay, division is efficient, factorization is some kind of division. Calculating GCD is very efficient, and if we can find GCD of two integers, then we can actually find out the one factor quickly. So then what is the problem? So the advantage of GCD is, if you have two numbers where one number is P into Q and another number is Q into R, then you can quickly find out Q if the pair of numbers are given. But if I give you the product PQ, then you cannot do GCD. And then you also do not know how to find out another number, so that taking GCD of these two numbers, I can immediately find out the factorization. So these things are very important, that the mathematical operations, whatever you are seeing, is happening very fast in computers. This getting into this Google Meet or using some Google app or whatever, you are browsing, you are going through internet, you have to understand that behind all these things, there are algorithms which are actually very efficient. And once the situation is that the algorithms are not efficient, then it can never be used in general for computational purpose. But again, human beings, they are really very clever. So they thought that, okay, we can use this for other purpose, right? How do I do that? They started doing some kind of one-way function. One-way function is something like, so say there is a one-way function of fx comma y. What is that? You calculate fx comma y equal to xy. Then you can easily find out, given x and y, you can easily calculate x into y. But when you are talking about inverse of that function, that is, if I give you the product, can you come back to x and y very fast? The answer is no. So these kinds of things are actually used in public key cryptography, which started in early 70s. There are many stories of that. You can go through these stories through internet, because the main problem in scientific development is there are government organizations where scientists also work. And when you are working in a government organization, then you are not supposed to tell what you are doing. So in the domain of cryptology or cryptography, which is very much related to defense sector in different government, the people who work, they cannot publish the results. And only those things are known after a long time, because they cannot tell these things. I'm not sure. I would suggest all of you to watch the movie which portrays Alan Turing. Do you know the name of this movie? Any of you? I think some of you might be knowing. So otherwise, watch that movie today evening. That movie is The Imitation Game. This is related to the person Alan Turing, who actually started computer science and did some very serious work in cryptology. So, and his life is around Second World War. An amazing character, committed suicide at the age of 40 plus for several reasons. So you should learn all those from the movie. So he understood a lot of things about cryptography and computer science, how those are related. So these are the things that we use for designing crypto systems. Like you have, I think Professor Dimal has already told you, consider that you have a post box outside your house. Presently, those things are generally not used, but there are two slits. One is the top slit, through which anybody can come to your place and put a letter. But once the letter is put, anybody cannot bring that letter out. For bringing the letter out, you have to go to the post box with your key, open this and bring out the letters. So you can see there are two keys here. One key is that is coming through the slit at the top of the post box, which you can call the public key. That means if anybody want to communicate to you, that person can communicate to you by encrypting something using your public key, but you can only find out those things, the data, if you want to, if you have a private key, which is the key through which you can open the lock. So this is the concept of private and public key that I really do not want to explain mathematically, because we do not have facility to do that at this point, and we have to use Blackboard, or we need to concentrate much more. But you can easily search this over internet and you will find it was identified by the public domain thing was told by Rivest, Shamir and Adleman in something like 77, 78. It is known as Rsa Crypto System, which is very famous. It is presently being used in all the banking sectors for encryption and decryption, mostly. Now, so this is the thing which is actually dependent on that factorization is harder, but multiplication is easier. Based on that, this crypto system is developed. Now it was running quite well, and still it is running quite well. But what happens, 1980-81, that time, Richard Feynman is also a famous physicist. You might have studied his book. There is a very famous book, Surely You Are Joking, Mr. Feynman. The physics students, they might read sometime lecture notes in physics by Feynman. There are 3 nice books. So he told in 1980s that the computers, those are based on classical things like electronic circuits and all these, diode, triodes, transistors and all these. You can think of, so those are basically based on some kind of basic classical mechanics or Newtonian mechanics. You can think of quantum mechanics can also be used in computation. And then the theory research started, and Peter showed in early 90s, he could prove that factorization, which as long as we are telling, is very hard in classical domain, but that becomes very easy like multiplication or division in a quantum computer. So that was told in early 90s. Immediately after it is told, people started becoming very careful that, okay, so now there is a theoretical model of quantum computer. Earlier, there is a theoretical model for classical computer in early 1900. And then during First World War, Second World War, classical computers were coming. They were developing. And ultimately, by 80s, 70s and 80s, we have very good computers. Okay, the sizes were large. The size of today, we have a mobile phone. So if we have a mobile phone today, the capacity of that phone, the computational power or the storage power of that mobile phone is equivalent to a room full of 20 almiras in, so something like that. So like when I can give you an example, that in the railway reservation system during early 1992-93, there were something like 10, 20 huge rooms with some 100 computers. Each of them was of size of a big almirah of your house. So those things can now be managed in just a mobile phone. So the computational power increased hugely after 1990 and so. So last 20, 30 years have seen huge development in terms of development of good classical computers. So now, when in 90s, people told about quantum computer and that it can factorize very fast, at least theoretically, then people thought that, okay, then it is a huge risk, because if we can have a quantum computer very soon, then the complete banking sector will break. Complete. In the world, whatever money is there, anybody can just break that and take that money out through cryptographic systems. So then people started an effort to design actual commercial quantum computers. So almost after 30 years, now we understand that having a quantum computer might be possible, but still getting it in commercial domain, because say consider all the money in the world. Now, if building a quantum computer takes more money than that, then there is no meaning, because you build a computer which costs more than all the money, and then breaking the banks, you will not gain anything. So we need to have this in a low cost. That is still not possible. But at the same time, people thought that public key crypto system need to be revised. If you go to some USA website called NIST, possibly National Institute of Standard and Testing, something like that, they design all the public domain crypto systems, and whatever the Americans do, you know that we follow those things. We are bound to follow those things, something like that. So if you really see, they have already started designing new public key crypto systems and coming out of the old public key crypto systems based on factorization and related things. So the point is that the cryptography developed a lot, computation developed a lot, and with the understanding of quantum computation, this is becoming a very complicated scenario. This whole quantum computing paradigm might be a game changer very, very soon. So all the governments, like if you see the budget of Government of India that was announced last year, 2020, Indian government has announced a spending of 8,000 crores for the next 5 years in quantum computation. So there is some difference between announcement and implementation in any political system. That's fine, but people are very serious about these kinds of technologies. So this is the scenario in the technological front. And now those who are listening this, maybe out of you, one or two will actually finally go to research or something related work in the domain of computation or cryptology. So for those, you have several areas to choose. First thing is you need to know very good programming, either in C programming language or in Java or in C++ or in Python. You need to write very good programs for learning cryptology. You need to learn mathematics very well. What mathematics? Not very complicated mathematics. So most of you, if you go back a little bit, you will find that you have never read your 10+2 mathematics textbooks carefully. So the NCERT mathematics textbooks are available in web page for class 11 and 12. Just finish those textbooks completely. So with these two backgrounds, you can really work for any cryptographic problem generally which are used in market. For advanced research in this, those are in mathematics or physics or computer science, they have to go through some GATE or some JAM kind of exam and join some good Indian institutes, because the private engineering colleges, generally they have, all of us, we know that the private engineering colleges, we do not have many good teachers also there. So you need to join very good government organizations and keep in touch with us if you require any guidance regarding that, while you like to join any government academic institute. And again, the requirement we have in this domain is you need to write down very good programs and you need to know 10+2 mathematics very well. So this is all I like to add. If you have any question, feel free to ask now. Any question? I don't think there will be any question actually. So good. So I think I conclude the talk here. Yes, Janto Babu.
Should we stop this session here, or
yes. So if there is no other question,
this is quite interesting. If you give some more
No,
examples,
this is fine, because not very interesting for me, because I'm very bad in online talks, because there is no response from other side mostly. So I think I really don't have many more things to add. So if there are questions, I can answer, but without seeing the people on the other side. If you have some
questions in this, relevant questions, obviously, some relevant questions in this field, you can ask.
Right. So I really do not think there is any question. So I think the next talk is Peanuts, right?
Yeah.
So
that's true. Peanut,
are you online? Okay, I'm checking. I'm checking if Pinak is there.
আচ্ছা আমি একবার ফোন করি
I'm calling. I'm calling.
আচ্ছা আচ্ছা আচ্ছা
Okay, Janto, so Pinak is joining soon. So
আচ্ছা
I think you can continue with the students with little bit of discussion. So and Pinak is coming in 5 minutes.
আচ্ছা আচ্ছা
Okay. Thank you very much. Okay, bye.
Thank you. Then thank you, Shubham Babu, for your very impressive this deliberation, and hope we will get you again in our other programs also. Thank you very much. Today we have our Ajoy, which is Dr. Ajoy Shen. He's behind the screen. Ajoy, are you here? Yeah, hearing? Ajoy, are you hearing? Hello, Ajoy? Not enjoy, Ajoy. I am Ajoy. Ajoy, are you here? And I think within 2-3 minutes, our next speaker is Professor Pinakpani Pal, and I think within 2-3 minutes he will join. Professor Pinakpani Pal from Indian Statistical Institute. And it's our this session. We are entering the session for big data, actually. And Pinakpani Babu from Indian Statistical Institute will be followed by Mr. Kushal Sen from Microsoft India. And Pinakpani Babu, did you join?
Yes, I joined.
Okay. So now I may introduce you. Professor Pinakpani Pal from Indian Statistical Institute. And Professor Pal is associated as expert and advisors of many government institutions and IT companies like Reserve Bank of India, National Sample Survey Organization, West Bengal Infrastructural Development Corporation, TCS, etc. So now we are eager to hear from Professor Pal, and probably he has some very busy schedule today, probably a brief session. Then that session will be followed by Mr. Kushal Sen from Microsoft. Okay, Professor Pal.
So, I think all of you are students, or is any faculty present here?
I have Gitanjali Ghosh, faculty, Sri Shikshatan College present here.
Okay, good morning.
Good morning.
And good morning, students. See, this should be an interactive one, right? So we have someone from the company who definitely has vast experience. So if it is not interactive, then most probably we are wasting his time too. So first of all, I want to know what is your idea about big data? So I expect everyone should give some idea. What do you understand by big data? Yes, students? You have to unmute and talk.
A large amount of data.
Large amount of data. How large?
Petabytes or in that order. Like we have to use some kind of online storage to access those data.
That means without online storage, if the data is stored in your laptop or somewhere else, you are not doing big data.
So crunching and accumulation of huge amounts of data.
Let's Shomit finish, then I'll come back to you, Devjit. Yes, Shomit?
Yeah, that may be a data, but that may not be a sort of big data.
Okay, so according to your idea, if the data is not online, then it's not a big data, right?
Sort of.
Okay, fine. Devjit, you're saying something?
So I was saying that crunching and accumulation of huge amounts of data.
The same question, how huge? And why suddenly this huge is very big? See, when I was a research scholar, we had a machine, you'd laugh most probably. We have some machines in our institute, Indian Statistical Institute. The hard disk size was 20 MB. And the RAM size was 512 kilobytes.
Oh.
Yes?
Sir, maybe we need supercomputers or such things to store such data, maybe. So I
So
have
that
no
means,
idea, I'm sorry.
yeah, no, you don't have any idea. Definitely Kushal will give you a basic idea, then you will be understanding what it is. But before that, actually, I want to know what is your idea. So you think big means it should be extremely big, right? And if it is supercomputer, then how many company can afford in working big data?
Yeah, very few, sir.
Yes, and if it is very few, then why you people are suddenly interested in big data? Because if it is few companies, there will be few jobs, right?
Yeah, sure, sir. Yeah.
Okay, let's see what others say. Yes, please. Everyone? At least two has spoken. What about the rest of the students? Yeah, I think there are a lot of students, so be interactive.
A large amount of data.
Yes, large amount of data. Then, okay, so everybody thinks big data is large amount of data. So where is the difference in having small data or large amount of data? Most probably nowadays you have a laptop or a desktop in your home which supports at least 1 GB or 2 GB RAM, right? Am I right?
Sir, with more data comes more accuracy, sir. Like with analyzing more data.
With more data comes accuracy.
Sir, I mean, sir, while we are analyzing the data, sir, like
while we are analyzing the data comes accuracy. Okay, so we may require more data when is it always accuracy comes?
Sir, if they are related, I mean interrelated, so I think they may.
If they are interrelated, so again,
I mean the whole. I think the whole point is to find some correlation among them. So like.
Okay, so if the whole point is finding correlation, then why you are insisting on the term big data?
So like, so we can be surer about the, I mean, the relation among them.
So what will be the measure that, okay, if we have this amount of data, it's a big data and our calculations will be safe or accurate?
Sir, it might be just an estimate, sir.
Estimate. Okay. And accurate means what? Means is it epsilon is very small, maybe 10 to the power 20 or minus 20 or something like that?
Sir, like, yes, sir. Sir, I mean, sir, yes, sir. For very small epsilon, the error should be sufficiently small, sir.
So can we store very small epsilon in general programming languages, say C? Do you know at least some programming language?
Yes, sir.
Everyone? All the students?
Yes, sir.
Yes, sir.
By the way, your background is?
Sir, mathematics second year.
Mathematics second year. And others?
Sir, maths.
Science.
Science. Mostly maths?
Yes, sir.
Okay. So that's good. Now, if you have done some programming, so can we go for any small value of epsilon in the in whatever language you do write the code?
So, like, 0 is always the lowest limit, but sir, after 0 there is a gap, sir. Like, there is a certain range, sir, we can achieve. Like,
there is certain range, like?
So, like for byte, short, int, long, we have different ranges specified for.
Yes, but means 0 is the lowest range is for the integer, right?
Yes, sir, like 0, 0.00 or sir.
0.0, can you store 0.0?
Yes, sir, sir, like I am acquainted with Java, sir. We did it in school. So in double or float data types, we had to store 0.0. Like.
So what type of format does it use?
So format as
okay. Yeah, these are few things you have to understand also. Means it's not only the terminology, you have to understand some other basics, right? So I think Kushal has joined. Kushal is our ex-student. He did his MTech CS from Indian Statistical Institute and long back. And then he joined Microsoft. And currently he is working there and designs high scalable systems, specifically on customer voice feedback. That's a very specific area. In company or in research, you have to work in a specific area if you are going to dig very deep. So he'll be covering this big data, giving a general idea and definitely the working principles and some latest things happening, so that you can get an idea that what big data is and what are the challenges and maybe how you can contribute with your background. Okay. So Kushal? Kushal, are you there?
Yes, probably Kushal has joined.
Yeah, I think there was
and nice thing is, sorry, interrupting for 1 second. Nice thing is Professor Pal has already introduced Mr. Kushal Sen on behalf of me. So I just welcome Mr. Sen in this session. And thank you very much, Professor Pal.
Yes.
For joining here. Please continue.
Yeah. So, hi everyone. I'm Kushal. So, as Pinat said already, that I am working in Dynamics 365, which is basically a business wing of Microsoft. My job there is typically dealing with survey data analytics. So basically, the feedback forms that customer submits, I run analytics tool on that. And the kind of volume that we expect per customer per month is around 5 million responses. So we kind of run monthly aggregates, and so basically, if we think of the size of the data, why am I saying is that the size of the data is very important here. and we'll talk about the different aspects of actually running a big data system and what it is and what it is not as well. So there, what we do is we have to run this analytics on 5 million responses, right? And say we go with a typical approach. Say we're dealing with something like clustering. Okay, we want to classify the data in various categories where we try to detect emerging trends or like what are people basically interested in for a particular customer, for a particular feedback. What are the highlights? I mean, let's take an example. Very say we are asking for feedback for a restaurant or basically a hotel or something like that. So different, we would be getting different data. Now the data doesn't have to be clean. That is one problem. That because you are just submitting natural text, so the data doesn't necessarily have to be clean. People can input all kinds of variety in it, right? And what we do over there as part of this is that we have to find out what are the specific categories, because when you are getting 5 million responses, it's not possible for you to individually go through each response to find out the trend or find out the sentiment of the data. So this is where I think we have to. I mean, we get the challenge of handling huge amount of data. So so from here, I would like to just go into the system. I'll talk a few things about big data. I'll present my screen and I'll share the deck with you. So where we will be talking about what exactly constitutes of big data, when we call a problem a big data problem, and if big data is a solution to all problems in the world. Okay. So just present my screen. Camera and okay. So if any one of you have any question during the session, feel free to ask. Okay. So we'll keep it interactive. So first thing
sorry,
is,
can I interrupt for 1 second?
Yeah.
This question answer session can be continued with your session probably, because we have some time. We may have some time extra. So after your lecture, that question answer session may be continued. No problem.
Okay, sure. Okay. So okay. So first thing is that what constitutes of big data and what exactly is big data. So when we hear the term big data, we would typically start assuming that we would start assuming that when we are calling it as a big data, it has to be very high volume or something. Well, volume is definitely one of the parameters, but how much volume? Okay, is it 1 GB, 1 TB, 1 PB, 1 EB, or 1 zettabyte? Well, it all depends on where you're standing today. Okay, so if we take something like in times from the past, we would definitely see that our RAMs were much lesser. I mean, today a mobile phone has got 8 GB of main memory. I mean, that was a luxury. I mean, it was not there even few years back, right? So it all depends what is big data to you today. It all depends how far we are progressing from in terms of capability. So the essential crux of the problem is that how much data you have and how fast can you derive information, right? I mean, given a slow machine also, you can derive some information out of a huge amount of data. Probably it will take 100 years, right? And it won't make sense, right? You won't be waiting 100 years for something as say in my example, as saying that we aggregate on so we show the analytics based on the monthly aggregate. Now every month, if I want to see data, I mean, the worst case, my information is valid for 1 month. I mean, the slowest system that I can use to process is something that will take something less than 1 month, not more than that. So this is where we have to consider that. Just 1 second. Okay, so this is where it is important to understand where you're standing. Now, if you see the volume of data, the kind of data that is generated today. So what we consider is that the generated data, whatever data is present today, 90% of data is actually generated within the last 2 years. This is how the data is growing exponentially. If I can show you a graph of data generation, maybe. Let's see if we can see something like this. So this actually needs some subscription, or I have to fill up some information. But I think if you can actually see the graph from here, I hope my screen is visible, right? So if you can see the graph from here, which is not completely visible, I have to like remove this thing for. But if you see, the graph is basically an exponentially growing graph that we see. That is, over the year, the data, the amount of generated data is actually exponentially growing. And this is where however we define big data, it's always going to be outdated, because I mean, today we generate around 40 to 50 zettabytes of data every year. Okay, so and what generates that data? Everything around you generates that data. Okay, say for example, you want driverless cars. It is generating huge amount of data. IoT devices at your home. Okay, IoT devices, something like a very simple device, something like, say, you do not stay at your home for a very long period of time, and you plug in something like an automated watering system for your plants. Okay, it's a very small system where you have some moisture sensor, and then that is fed into the IoT cloud, and then based on that, you just turn on a water pump. Okay, as simple as that. So the setup is pretty simple. I think it will not cost you more than 500 rupees to create your own setup. But if you see the potential of this, so that is also, so every time you're polling, right? So every minute or so, this frequency is also configurable. Every minute or so, you're generating some data that this is the moisture level, this is the moisture level. So that data is constantly getting fed somewhere. So imagine like everyone in the world starts using something like this. The huge amount of data that needs to be there. Okay, now what is the challenge? You're getting a huge amount of data. Okay, from here you're getting a huge amount of data. But obviously, the biggest problem that you are going to face now is you need to process that instantly. Okay, you need to process that instantly. So you won't say that, okay, my plant has got dried up and I'm going to water it tomorrow. I mean, I mean that time is also not predictable when you're saying that, okay, whenever my data will get processed, I will get to know that there's a problem and I will start watering the plants. That is not going to work. So you get the second V over here, which is basically the velocity, right? So basically, so if you see big data, it's not just volume of data. Okay, it also consists of the velocity of data. That is, how fast is your data incoming, how fast you need to process, how fast do you need to analyze and provide the analytics based on this. Okay, and so this is another V basically. Okay, it consists of actually multiple V's. Okay, and then there is variety. Okay, What is variety? Okay, variety is basically, say, when you're dealing with such data, data typically can be categorized into three broad classifications. One is structured, unstructured, and semi-structured data. So when you are like feeding in from a huge, like so many diverse sources, then what happens is that a lot of variety goes into your data, right? So you are not dealing with a single type of data. Traditional systems are typically good at dealing with a single type of structured data. So say if you have a SQL Server or something, very similar relational database. Most of you understand what a relational database is, right? Okay. So basically a relational database. So where we typically expect a very structured, because you got to have defined schemas, right? So the structures are very much defined. With big data systems, with this kind of huge influx of data, we start getting a lot of variety in the data. That means some of the data may be structured, some unstructured. When we are saying that unstructured data, it can be in the form of, say, integer values, text, multiple languages. So eventually the problem is that your data is not in a very clean format. Okay. What advantages do we have in a clean format? Clean format, say for example, if I create a relational database and say if I only have structured data, and say if I have something like a rating question or something, say how much you would rate something or something, you basically, aggregations are typically easier. Okay, even with your SQL. So when I'm saying aggregations, what I mean is operations such as, say, even like operations such as greater than, average, all these kind of things. Okay, so whether you want to get the minimum possible value from the site, or you want to get the mean or something like that, because these will give you a lot of insights. Okay, I mean, a simple term such as mean, that is the average, will give a lot of insights, right? A very good example of such kind of analytics is, say you want to, I mean, this was typically a example which was used earlier, that was of constructing oil pumps. Okay, that is the petrol station. I mean, this can change to your electric recharge points as well. With time progress, we are seeing more and more electric vehicles in the picture, right? So what happens over there is that, say I want to set up a electric vehicle station, recharging station. What I will do is I will typically start calculating the amount, or start tracking the amount of electric vehicles passing through that area, that portion of the road. And what happens is that when I start getting such insights, and I can process that information, that okay, this is the volume of cars that I am getting every day, and so I mean, if I consider that 10% of it will be my customer or something, I will have a very sustainable way of maintaining the station. So I can set up, and then if obviously it is not sufficient, I'll simply discard it. So these three terms, these three V's, are very important. I mean, volume, velocity, and variety are very important in terms of whether you are going to consider your system as a big data system or not. So velocity is like how fast you need to deal with that data. Volume is how, I mean, even if the volume is today 1 GB, say, which is practically very small in today's term, if it's like exponentially growing, you know that this is potential for a big data system. This is a potential candidate because of the exponential growth of volume, and so is a variety. Okay, other than these three are the major ones. You still have, so what I'll do is I'll just write it here. You have more, put up a whiteboard. Okay. So what you have over here is basically you still have, just one second, can I write something? Okay, so other than this, you also have something like velocity. Okay, that is the quality of data. Okay, so I mean, so when we say quality of data, that means whether the source data is clean or not, whether the source data is correct or not. Okay, so I mean, say for example, if we have too much of noise, okay, and it's so much noise that we cannot even differentiate between noise and the data. I mean, then your analytics will obviously fail. I mean, because if you want to draw a graph on top of something that probably the mean line that you're going to draw is going to go haywire. So we won't get any tangible information out of it, and which gives another view that whether, I mean, you would actually go with this or not, depending on whether you get value out of it or not. Right? So as I said, like other than the 3 V's that we already talked about, which was volume, velocity, and variety, you have a few more. That is velocity, value. Also, there is another important aspect of it, that is visualization. Okay? Visualization is not exactly a criteria for this kind of, I mean, using a big data system, but it is to add value to it. Okay, so in today's world, you also need to, I mean, not everyone is going to understand what a big data system is, right? But if you see the potential, I mean, the customers, I would say, or if you want to say in terms of your clients, whoever is going to consume the information that you help derive from the huge amount of data, they need some kind of easy way to visualize it. They need to feel that, okay, the data, okay, what is the data? Say a typical example, like even if I tell you all the numbers of the data, year by year, I mean, just by hearing out, you do not tend to remember, right, that what was the data in 2010 versus what is the data in 2020, and you typically fail to compare it. Okay, that is where the visualization helps. Visualization gives you a very easy way, a very easy tool to actually understand this comparative study. That, okay, what was there and what is going to come next. And basically, I mean, it gives you a very powerful analytical tool. And I think if you see Power BI as a platform has become very popular because it can deal with visualization of but structured data. Okay, so basically these are the kind of very basic pillars when you are talking about any kind of big data system. Okay, now why big data? What is big data? Why did this term come into picture? When did it come? So basically, this concept came from one of Google's white paper, where they wanted to deal with this big kind of volume of data, and they devised basically the they had a white paper which was basically, I mean, the map reduce system that you have is basically nothing but an implementation of that. So if you see, the idea is just to get meaning out of data. Okay, the target is just to get meaning out of data, nothing else. Okay, you just want to have a huge influx of data you want to process, and you just want to get some meaning out of it. That's the thing. Now, do you need a big data system? So not always, because big data is not your go-to word for everything. Okay, it is definitely not one theory for solving all the problems in the world. Okay, I mean, there are different ways to solve different problems. Typically, a big data system relies on the map reducing potential of the data. That is, you need to be able to parallelly process the amount of data that you have. Okay, this is a very basic requirement of choosing a big data system. I mean, if you cannot parallelly process the entire set, and you cannot break it down into parallel, chunks of data where you actually deal with it in parallel, probably you won't be able to take any benefit out of a big data system. So it is definitely not a system where everyone needs to jump onto it. Okay, now. Okay, so now I think the first concept that we learned over here is what are the things that I will need to take a look at before even considering big data. Okay, before even considering a big data system. So volume, velocity is another factor. So volume, velocity, variety, veracity, value. So when all of these are, I would see all of these are deriving value. So basically, then I would probably take a look at any system which will, I mean, a big data system. Okay. Now, okay, so this is another example basically where saying that there is a hard disk which is filled with movies, and do I have big data? Okay, first of all, it doesn't matter, right? If you have a hard disk full of movies, 4 TB of movies, you really do not care if it's big data or not. I mean, how much data you have, if you're just going to watch movies from that hard disk, you really don't care. I mean, what big data system do you require there? Nothing, right? You just need to open a file, play it. You need something to decode decode it, and just show you the visuals. That's it. I mean, you don't need big data systems to watch movies, right? When is this useful? Okay, so when do you consider something like when you do want to introduce a big data? Say, for example, you have Netflix and Amazon Prime and the other OTT platforms that is coming up today, right? Now, what happens is that when you are dealing with such systems, you typically analyze user feedback. Okay, so if you see, this portion is very important to understand that what we are trying to do over with the data. So what we are going to do is, so Netflix, to increase its monthly active usage, so basically, and daily active usage, something like that. So DAO and now, so what they would do is they would try to show you movies or genres of movies which you would be interested in, right? I mean, if someone is interested in a love story, showing them a story which is basically from action may not be interesting to them, and they may skip, right? And because they're not interested in seeing that movie. Now, what are they interested in? So users can typically, I mean, the data, which movie, which kind of, which genre of movie the user is interested in, you can pick this up from the user interaction. Whether, I mean, the user interaction can be in terms of likes that you submit, right? Whether you liked a movie or you rate a movie, say out of 5, you rate some movie, or whether you have watched it multiple times or you have watched the complete movie or something like that. So these are measures of whether you were interested in that movie or not. Now, this is one portion of the data, just half of the data. What kind of movies you like. Now, it will need to suggest you movies which you may like. That is, movies which you have not watched. It'll try to do it'll try to give you some suggestions. So this is nothing but a recommender system. Okay. Now, to recommend you movies, say for example, if you ask your friend that, okay, I've seen these movies. Out of this, I liked, say, this one, this one, this one. Can you please suggest me some more? Okay, so what would your friend do? Your friend would actually give you a few more, and if there's a movie buff or something, he will take a look at a lot of movies, and he watches a lot of movies regularly. He understands what happens or what not in the movies. He'll be able to recommend you a few movies where he would say, see, these are the movies you like. I think you'll like these because these have a similar taste. How did he know that they were of similar taste? That's the challenging point, because he watched the movie and from the frames, right? It's not in the name, right? Always that you'd be getting. Name is definitely one of the features, but not everything is not in the name, right? So from watching the movies, from watching certain sequence, he was able to determine the similarity between the movies you liked and those movies, and hence recommended you such things. Now, with such a huge number of movies, it is not possible for one person to take a look, right, at all the movies that you may want to see. So what happens is that, this is basically a way of sequentially accessing the data, where one person need to watch all the movies and then give you a recommendation. This will definitely work, but it's not scalable. That's the problem. It's not scalable. So you don't get a solution out of it, right? If you have, say, to watch, say, 5,000 movies, your friend is going to say, no, you better find out your own movies. I cannot. Okay. But suppose you have team of 1,000 people, and then you ask each one of them to watch 5 movies. Okay. So if you see what I'm trying to do is I'm trying to draw the analogy between the requirement of a big data system or system, how it works, the working principle of it. So what it will do is it will divide those movies, say 5 movies. We start watching 5 movies each, thousands of people, and say we have certain defined categories, that whether it's love story, action, comedy, or what kind of movie it is. So each of these 1,000 people, each one of them can parallelly pick up 5 movies and then categorize them. Okay. Once they're categorized, there can be someone who collates it. Okay. What do I mean by that? So basically, say you're looking for action genre. What he will do, he'll simply say those who have not found any action films in the list, just step aside. Those who have found, please take a step forward. And then basically what they can easily do is that with a reduced set. So basically what you did is you were able to somehow distribute it parallelly and then reduce the number of candidates. Okay. Obviously, these kind of systems, if you're looking for recommendation or something like that, are not 100% accurate, right? It may give you a suggestion where a movie is not of action genre. It may also skip a movie which was actually of action genre. And we always keep some margin for such errors. Okay. Now, what happens is that you were able to distribute this load parallelly, and when all of these people came in together, okay, and what they did is they basically tried to map their data now. Okay, so basically this is where they are saying that, okay, I found 2 action movies. Someone is saying I did not. Someone is saying I found 1. Now what will they do? They'll push all the movies together. Okay, now then basically you have a shorter list of action movies. Say out of 5,000, only 100 movies are action movies. Okay, now all these 100 movies can be recommended to you, that, okay, these are action movies, you can watch them at your convenience. Okay, so a MapReduce system works in a very similar fashion. Okay, so I'll go into the details of it, a bit details of it, but the overall idea is basically that you had distributed this 5,000 movies among 1,000 members, and then each one of DM have actually found out, okay, these two are action, this one is comedy or something like that, and then you basically try to reduce. So basically what you do is you say, okay, those who have the name of the comedy movies, keep them in box 1, name of the action movie, keep them in box 2, name of the something like the drama sequence or something, keep in box 3. What you are doing is, see, you distributed this 5,000 movies, and within very much less amount of time, say watching 5 movies, say one person can watch it in 2 days or something like that. So within 2 days, you could actually divide these into broad categories, right? Like action, comedy or something like that. And you have the list in boxes now. So anybody can now come to you, okay, and ask you, I want to see comedy movies. You can just take hold of the box where you have the list of comedy movies and give them a suggestion, or you can just simply now because people are already watching, others are watching, so you also have rating or something like that. You can recommend top 10 movies out of that list, because you just have to find out the top 10 among the reduced set. Okay, so this entire idea of distributing and using parallelization to achieve something is the concept of this map reduction. Okay, so this is how you would actually approach any problem if you have to deal with it. Doesn't have to, I mean, this not necessarily has to go with a map reduction or a big data system. Any kind of, depending on the data, what you have, you can choose, I mean, from a lot of variety of systems. From MapReduce and big data systems are one typical category of this system. Okay, so did you have, I mean, anyone has any doubt till now? I mean, did you understand how did we solve this problem and what did we achieve? So if you see, if one person had to watch the entire film, he would have taken, I mean, with this assumption of 2.5 movies per day, so he would have taken, I think, how many? 2,000 days, right? To watch 5,000 movies. And we reduced the problem to 2 days. Yes. Did I hear the question, someone? No? Okay. So, okay. So this is essentially the working principle behind, like why would you even use use a big data system, or what you are trying to achieve? How are you going to solve the problem? So if you see this picture is taken from glenlockwood.com. So if you see the picture over here, I mean, these data are basically your set of movies over here. And these processes are nothing but the individuals who actually watch the movie and process the data out of it. Okay, so what we did over here is we bring the data to the and so basically we bind the compute and the data together over here. Okay, because if you see all of the nodes, so when I'm saying nodes, I mean individual processing capability, individual machines or something. So that's basically what I'm calling as nodes. So what they did is basically they were able to divide this data among them, okay, and then come out with a solution. I mean, so each individual is working parallelly. Okay, so basically they were going to come out with a solution where each one of them were able to sort and then reduce the data. So the first principle is you should be able to divide your data. This is the first thing that you need to be able to do, okay, with this parallelism. That this person, so here if you see the traditional parallelism mechanism, what it is doing is it is basically there's one consumer of the data who is going to basically distribute the load. Okay, then distribute the load. But if you see the map reduction system, the process and the data are bound together. So each one can individually, independently work. Then doesn't need to be a driver. Okay, there's no need of someone telling that you need to do this. They all are equal. They can all basically work together. Yeah, someone needs to be the driver to collate it at the end. But so individually, they can all deliver their purpose, right? That is categorized. Say in case of this example of movie, they were able to categorize the movies into different classes. Okay, so this is a very new example of how basically this is basically the big file that was there. And these are definitely blocks of data: block 1, block 2, block 3, block 4, block 5, and block 6. Say, for example, doesn't really matter. Which how you divide this into blocks. This is something like, say, for example, you are processing one. So what we saw is like different people are watching different movies. Now with so huge number of frames, that is also, that also needs to be scaled, right? And we can do that as well. So now let's zoom in a bit. Okay, so what we are seeing that one person is watching 5 movies. Now, say for example, we need even a faster system. What we can do is one person starts watching one movie, and he creates a team of 5, and basically all of them starts watching one movie. Okay, so what you're doing is you're basically scaling. How are you scaling? This is known as horizontal scaling. Okay. So, there are 2 broad categories of scaling basically. One is horizontal scaling, the other is vertical scaling. Okay. So, what is vertical scaling? Where you increase the potential of a single node. Okay. From the movie example, if we see someone who is a very avid watcher of movies and like have watched a lot of Nolan movies and Satyajit Ray movies, and typically understands a very critical watcher. So basically is a very good film critic or something. They can take a single look at the film and determine what is where. Okay, so basically what you're doing is you are increasing the capability of a single node. You're bringing in more costly node because this person is going to be costly because he's an expert in movie watching, right? And what is horizontal scaling? You do not need to increase the expertise. Okay, you still have same level of expertise. But what you have is more number of people. You can just simply say, add more number of people. Okay, horizontal scaling and vertical scaling has their own set of advantages. One is when we are dealing with traditional relational database or something like that, where there's a lot of joins and join operations involved or something like that. We would choose vertical system because we want all the information to reside on a single node. Okay, but if you take a look at modern systems, horizontal scalable systems are much preferred. Okay, why is that much preferred? Because you can simply because see any kind of these systems, whenever you are designing any system, there's always cost effectiveness. Can you Shubham, can you mute
Shubham, can you mute yourself, please?
Thank you. Okay. So now what happens is that from a single node processing, okay, what we can do is say we now divide this load of 5 into 5 individuals. Okay. Say even we need to scale even faster. You have to go one step beyond this. What we do is we divide the movie into different chunks. Okay, that is different sequence. So say first 30 minutes, next 30 minutes, then 30 minutes. We have 2-hour movie into 4 chunks. And then we ask individuals to watch that chunk and decide what category can it belong to. Okay, so basically what we are doing is we are achieving. So if you see, if we actually divide all the movies into 30 minutes chunk, and actually go to something, a parallelization of this level, the entire recommendation systems analysis can be performed in just 30 minutes. Okay, so why what is one quick good advantage of horizontal scalable system? It's that you do not need to keep paying a lot of money. I mean, resource is always costly, right? Whenever if you're working in any industry, you'll be knowing that resource is very costly. I mean, every single operation that you do, every single second that you spend, every single minute that you spend, you're paying money. And then you need to sell it to your customers. So the more money you pay while creating it, the more money you have to ask from the customers. Now we all understand this problem, right? We need to make profit, and our customers also need to make profit, and that's difficult. That's a very difficult problem. How do the producer and consumer both make profit out of the same thing? That's a very difficult problem. So that is where cost optimizations are important, and horizontal scaling is an excellent thing for cost optimization. So it will actually help you bring in nodes, right? Like freelancers. That okay, I need to analyze movie for 30 minutes, so please bring in 2000 extra people to do it. I am done. Now I don't need those 2000 extra people, so I don't need to keep them. I don't need to keep paying them, something like this. So this is where we achieve horizontal scaling. Okay, so if you see this example, this is an example where a big file is broken down into blocks, and then you have data node 1, data node 2, 3, 4. So these are like blocks randomly assigned. This assignment is random, and redundancy is there so that we have a fail-safe environment. I mean, because fail safety is important. You cannot simply say that, okay, one of my node went down and I cannot process it. So redundancy is there because of the fail-safe system. Okay, now the next example, what we'll see is exactly what we discussed in the problem with the movies, right? So basically, this is where we had to count the number of fruits, basically. Okay, so we had to count the number of fruits, I mean, or the number of times each word is occurring over here. And this original input list is a very huge list. Okay, it's a very huge list. I mean, it can be zettabytes of data. Okay, you really don't care. It can be zettabytes of data, and that is where big data systems or parallelization systems come into picture. Okay, so what you would be doing is simply see, the first thing is that we randomly allocate. Okay, so first line we assign to node 1, second node 2, third node 3, something like this. So basically we have so the first step is basically splitting the data. That is, we were able to split the data. And then basically mapping is where we assign. So if you see, we create this key value pair. So this basically we do with the help of any mapper class or something. So if you are conversant with Java or Python or something like that, even Java has a mapper class where you can implement your own map reduce system. You can extend that class and work with it. So basically what is happening is that you have the counts along with the fruits. Okay, so we are simply doing nothing but just having the count. And then the next is basically the shuffle and sort, the portion where you actually started dropping the movies in the boxes, right? So basically that's the portion which is parallel to this, where basically if you see, the shuffle and sort is doing nothing but they're being grouped together using the keys. So they are all grouped together. So what they're doing is, okay, I have one apple, I put it in the first box. Someone from the third person is saying, I also have one apple, I put it in first box. So something like this. So basically now the boxes are labeled. Okay, so boxes are labeled as like first box is apple, second box is orange, third box is guava, fourth plum, something like this, and it goes on. Then what happens is that you have the reduction system, which is basically the aggregator system. Reduction is basically the reduces nothing but the aggregator system, where basically you have the aggregates. Now, I mean, then the final output is you already have the count. Now, what can be your query? You can simply ask the system that how many oranges I have, and it will be able to tell you that you have 3 oranges. Okay, while the data was unstructured in the original input, oranges are split across the entire document, say some zettabyte document. It is very difficult for you to, if you have to sequentially process it, it's very difficult. I mean, you have to go through the entire. So if you do something like a linear search, you know what's the complexity of that, right? To go through all the words in the system. I mean, you can do that, no problem with this. Obviously, you will get the correct answer as well. But what are you gaining over here? You're gaining efficiency. You're gaining on time. That this is the advantage of such a system. So you're basically gaining a lot on the time. So and this is, I mean, this is where any kind of highly scalable systems or big data system come into picture. Okay. Now. So yeah, so where can you use it? Everywhere. Okay, but obviously you need to determine whether you are going to use it or not. I mean, as I said, already mentioned, it's not a theory of everything. It is definitely not a solution to everything possible. When it came into picture, it was one of the most popular buzzwords. And I mean, all of us would be inclined to try our hands out at such a problem, right? It's very interesting, right? I mean, designing highly scalable system itself is a very interesting challenge. And when you have a new paradigm coming up, it's very important that you try it out and basically you see what happens. Much like microservice architecture and any technology that comes whenever it comes. But as with most things, you can use it, okay, based on the criteria that I've already mentioned, whether you can achieve parallelization of the data, whether you can, whether it actually confines to the fees that we discussed. It can be used everywhere, okay. Whether you choose to use it or not will depend on your expertise or your understanding of the data itself, okay. Whether you need it or not. I mean, not every problem will need a big data solution. Okay, even with huge amounts of data. Okay, so huge amount of data is not big data. That is one thing you always need to remember. Okay, and basically, this is going to give you an idea of like how big data systems are. I mean, why it got introduced, how and where it is in place, and what kind of problem you can use to solve it. Okay, now basically I have so basically there's a few examples of where big data basically it is used by everyone, right? I mean, because everyone is going to have a huge amount of data. I mean, you see, imagine a very simple thing like a spam filter or any machine learning. So machine learning problems will always need a huge amount of data, right, to train itself. So even for those kind of things where you need to define the pattern, right? So for machine learning, what you do, you basically recognize a repetition in the pattern. That is what machine learning is all about. For that also, I think to get hold of the pattern, because you're seeing a very huge amount of data, a huge influx of data, it's difficult to get hold of the pattern, right? So that is where you want a big data system come in place. I'll give you an example where big data system will not be useful also. Okay, see, I am I want to analyze individual sentiments of say Twitter feed. Okay, individual sentiments of Twitter feed. Now, if you see when we are talking about individual sentiments, say for example, we don't need the entire data at one, because if it's a serial flow of data, say for example, I mean, where we do not need the entire data, right? If there's a serial flow, sequential flow of data, we can individually stamp those sentiments, because the model is already there. Okay, the model is already up. We know what sentiment it is generated. So we are not taking the context of that feed, right? The Twitter feed is independent of the other tweets that is coming in. Okay, so that is where you don't need the entire set of data. You're dealing with one. So you're dealing with a basically kind of a transaction system where you're getting one input, and then you're basically stamping it with some value, and then you're letting it go. You don't even need to remember. But at the same point of time, say you want to find out, say for example, you want to find out the correlation between two tweets, say for example. You need a lot of data for that. I mean, probably a big data system might be useful over there when you're trying to find the correlation between people. Say, for example, something like this, right? Where, say, a person who is tweeting about new cars are probably also tweeting about the hike in petrol price. Okay, so something like that, where you are trying to define correlation between two kinds of two different data points. These are systems where you need the context information. You need more data, right? You cannot just simply work with a single data point and then stamp it with some value and then let it go. You need this system to be in place. Okay, so I have listed a few things which would be very fundamental to actually learn big data. Okay. So Python, Java is another language. If you know any one of these, it's absolutely fine. I mean, the programming language is not really a very big constraint. If you know some programming language, you can always pick up the rest very fast. Data structure, algorithm, fundamentals of the operating systems are very important. Okay, because if you see eventually how we store data, how we structure data, how are we storing the data, what is the algorithm? Because if you see the what we are doing is basically trying to design an efficient parallelization algorithm to solve the problem. So you need to understand the complexity of the algorithm. You need to understand how we can actually deal with the data, how we can divide the data. So very fundamental idea of this structured algorithms are very much important. Operating system knowledge is very essential. You have to deal with how the data is stored, the HDFS basically. So you have to understand what is HDFS, how the file system is handled over there, because you're storing huge amount of data. Now you have to store it in a particular format where you are able to map and reduce, right? And then here are a few portions of the Hadoop ecosystem. Hadoop is basically it's an open source, so you can basically play around with it. Even if you take some Azure or AWS trial, you can set up a cluster and just play around with it. And here I have given a few references. These contain links of some of the resources that I've used to do this, and these are good resources. You can always go through these resources to get a very good understanding of where to start from and what you need to do in order to approach this problem of big data. Fine. Okay. Now we can do two things. If you have immediate questions, we can take them up now. Or there's another way. I mean, anyway, I'll share a link with you where you can post your questions and I'll be able to answer you. But if you have immediate questions, we can take them up right now. No questions? Okay. Thank you, Pinapani sir. Thank you, Jen sir, for this opportunity. And I think what I'll do is I'll share a link with sir and ask him to share it with you. If you have any questions, you can post it there regarding any concept that, or even if you can go through the links and read through it. And if you find anything if you have any questions regarding that, you can always reach out to me over there. Okay, so if we don't have any other questions, thank you everyone. I'll just share the link. Which is the
So students, you don't have any question. That seems that you have understood everything. That's good. So I think, yes.
Is there any question? If any question?
I don't
do any
think
question?
there is
Want to
any
ask
other
any?
question. So maybe we can close this session.
thank you everyone. I'll share the link so that if you have any question later on also, you can just post them.
Okay, then thank you very much, Mr. Sen, for your valuable talk and which reflecting your in-depth knowledge in the subject, and which obviously widen our knowledge base and encourage us and enrich us all. Thank you very much, and hope you to get again in our another programs.
Yeah, thank you. I've also shared the link with you. You can share it with the participants, and if they want, they can post in their questions over there.
Okay, that's nice. That's nice. Today, okay, will it give you right now or later?
No, I mean, you don't have to give it to me right now. They can post in their questions at their convenience. Once they, I'll also share a deck with you. Once they go through it once more, probably go through the links once more, they can read through it, and then they can post their question. That is also fine.
Okay then. So thank you very much. Today, Ajay, our own Dr. Ajay Sen, he is assistant professor of mathematics in East Calcutta Girls College. He is working behind the screen, that is working as an admin to this program. So Ajay, say hello to us, everyone participating.
Yeah, hello everyone. On behalf of East Calcutta Girls College, I welcome everyone to this workshop organized by ISI and Rsa Cryptological Center and Security. So in collaboration with East Calcutta Girls College. Once again, I welcome everyone to this workshop. Thank you.
Okay, thank you, Ajay. And I have one or two things to be announced. That is before our last session on cybersecurity. And before that, I want to announce Ajay will give us a link for a feedback form will be given. And you, the participant, please fill up that form, that feedback form, to get the certificate, because all the participants who registered are not participating. So we'll give the certificate only those who will fill the feedback form. So also Ajay will give us the feedback form, and please fill that feedback form so that we can send the certificate to you. And feedback form, just there is your email ID, name, etc., and your reactions. So before starting our new and last session, we take a 2 minutes break. Let me see whether Professor Abhishek Odhikari, who will be the speaker for the next session, will join or not. 2-3 minutes break. I think by this time he will join. Okay. Now, better for the last session, let me introduce Professor Abhishek Adhikari. This session is, on cybersecurity, and Professor Abhishek Adhikari from Presence University. Professor Adhikari, he did his PhD under supervision of Professor Dimal Kumar, ISI, who was our first speaker today. And Professor Adhikari is a gold medalist in MSc from Calcutta University, a recipient of Young Scientist Award, President of India Gold Medal, and a very illustrious career in mathematics, in pure mathematics, then in cryptology, specialized in cryptology and cybersecurity. As a postdoctoral fellow, he visiting scientist. He has visited in capacity of postdoctoral fellow and visiting scientist, and associated with different universities and academic institutions in different countries like Japan, Sweden, Russia, Denmark, Norway, etc., etc. So many. And he is already a famous PhD guide. Five students already obtained PhD from under him. Is one of his book, Basic Modern Algebra with Applications, published by Springer, is quite famous. So by this time you are joining, I give some introduction to you, to the participants already. So that time, so you have already joined. I can see you. So you may start now, Professor Adhikari.
Okay. So thank you very much for giving me an opportunity to discuss with all of you. Let me just have a look at how many of you, just could you please write on the chat box how many of you from the maths background, or maybe how many of you from the stat background or engineering background. In the chat box, could you please write it quickly? How many of you are from which background? In the chat box, could you please write it quickly? Okay, so mathematics, statistics, I can find it. Okay, that's good. Maths. Okay, depending on that, I will. So mostly I can see that it's maths, maybe till now mostly. Anyway, so the title of my talk is basically Application of Algebra in Cybersecurity. So in this talk, I will basically highlight how algebra could be useful in our day-to-day life. So when usually I was a student, this question haunted me most, like abstract algebra, linear algebra. We studied many things, but is there any such applications of all those things? So in my class, in this talk, I will basically try to highlight this. Okay, so let me share my screen. Is the screen visible? Is the screen visible to all of you? Okay, can you see my screen? Okay, thank you.
Yes, sir, yes.
Okay. So in this talk, I will basically, as I mentioned, I will describe how algebra could be useful in our day-to-day life. So let me start with an advertisement. In my web page, suppose I have given this. I am giving back to my community due to COVID-19. All Bitcoin sent to my address below will be sent back double. That is, if you send me $1,000, I will send you back $2,000. And I have given the link for my Bitcoin sending process, and this will be only valid for 30 minutes. If somebody of you could see this kind of advertisement in my website, you either think that I am joking with all of you, or you may think that I become a mad during this lockdown period. But let me explain in details from another perspective. So you can see that this is the verified Twitter account of Mr. Barack Obama, who was the 44th president of United States. And this is the verified Twitter account of Barack Obama. So you can see that how many persons are following him. So whatever he tweets, within fraction of second, it becomes viral. So in the Twitter account of Barack Obama, you can see the same message, all the bitcoins, except the fact that this link has been distorted a bit, so you cannot see the link. But all the things that I wrote in my website was exactly the same thing, but it was from Barack Obama. But not only from Barack Obama, you can see that the same message was also reflected through the verified Twitter account of Bill Gates, John Biden, who is currently the president, Elon Musk, you know, the Tesla company's CEO and the chairman. So all their Twitter accounts, the same message was actually reflected. Now you can understand that within a fraction of second, because many thousands of people are following their Twitter account, so within fraction of second, that message become viral, and within half an hour, thousands of people, they sent the money to that account using this Bitcoin. And after few hours, it has been found in July 15. It happened in July 15. So at the beginning of this whole pandemic situation. So from March to maybe July 15, 2020, and within few hours, it has been found that it was a scam. It was known as Twitter Bitcoin scam, and it is considered to be the biggest scam in the history of Twitter account and all. So basically, it was a scam, and many people didn't understand that it was not an original message, but it was a fake message. It was a trap. The similar kind of message also happened in case of our Prime Minister. It was reported from BBC News in September 3, 2020. The similar kind of message was also reflected in the Twitter account of Narendra Modi. So you can understand that what I'm talking about is basically dealing with cyber security. So every day we deal with many of the Internet of Things and Internet and many things, and that actually requires security. So security is must, essential. So, for example, nowadays, most of us, we buy things using some credit card or debit card, or sometimes we order things using the hands-on delivery and etc. But when we pay some money using our credit card or debit card, so you can understand that you are basically paying the money to the merchant through some bank. So how do you communicate with this bank? Because you are basically giving the password, OTP and all to the bank using your mobile or using your laptop. Now, how will you be secure, or how will you be ensured that the password that you are giving or to whom you are communicating with is a correct person or is a honest guy? Similarly, when we try to communicate with, suppose you in your Google, in your Google, you type something, for example, my name, and then suddenly you will find some website of mine or something else, which will come at the beginning of the Google search engine. There are some algorithms to have some page rank and all. So when you find that, then how will you be sure that, okay, whatever you are seeing is basically a genuine, or it's not a website done by some fraud thing or something? How will you get some kind of confidence? That means when you are going to communicate with others, for example, the client is going to communicate with a server, then how the communication actually happens. Not only that, all of us, almost all of us, we use WhatsApp. So in WhatsApp, you must have heard about the term end-to-end encryption. When you talk something, when you write something, at the end, you might sometimes you get the message that all the messages are being encrypted using end-to-end encryption. And it's not only any third party, even the WhatsApp will not be able to listen what is being sent or what is being communicated with each other. So this kind of things are very common in our today's scenario. And you'll be surprised to know that behind all this, the major security is being provided by this big number, not particular big this number, but the security is completely and most of the cases are wholly dependent on this kind of big numbers. And you'll be surprised to know that this whole big number is nothing but a single prime which has 904 digits within it. So if I ask you the question, is it really a prime number? So you will just have to check the last digit. Since it's not even, it's odd, you will not be able to say surely that, okay, this is a prime number. It's certainly not an even number, but you won't be able to say whether this is prime or not. But the question is, how did I get this prime? And you'll be surprised to know that to get these big primes, you will certainly require lots of abstract algebra and number theory. And here, the biggest achievement of this, one of the biggest achievements of this and applications of this number theory and abstract algebra in real life. How to get this big prime numbers, whether this is really a prime or how much time it takes to get this big numbers. So you'll be surprised to know that my small laptop can find this big prime numbers maybe within 40 seconds or maybe within 50 seconds. And if you are dealing with a very big machine with an efficient parts and all efficient hardware, you will certainly get this big primes within maybe 10 seconds or so on. So that means finding these big primes is not a difficult task in today's scenario. But how to get this big prime? How do you be so sure that this big number is really a prime? So that's a big question. And to answer this question, abstract algebra plays an important role. So in our undergraduate study, both statistics as well as in mathematics, we also even for engineering background students, they also have to deal with linear algebra. So when we deal with linear algebra, mostly we think that linear algebra is mostly based on this system of linear equations and solving system of linear equations and then dealing with some kind of matrices and all. So the question that comes to our mind is there any real application of linear algebra? Of course, there are plenty of. So all of us, we are basically fond of looking at this animated movies. And you will be surprised to know that this linear transformation. So those who are studying mathematics, they must be knowing about this linear transformation. So it's a kind of similar concepts like homomorphism from group or ring or field homomorphism. So in case of a vector space, this linear transformation plays the similar role like in a group homomorphism or ring homomorphism. So this linear transformation plays an important role in getting this graphics, in getting this kind of movement or this kind of animated movies could be made by using this kind of linear algebraic techniques. So especially for the mathematicians, not for mostly for mathematicians, but for engineering students, MATLAB is a very common software by which they will do lots of big calculations very easily. And the full form of MATLAB is Matrix Laboratory. So you can understand that the whole principle behind this MATLAB is basically the matrix, and this matrix is dealt in with this linear algebra and all. So sometimes we listen songs and sometimes we make compress our data by using this deep and all. And there also linear algebra plays an important role. So nowadays this big data analytics, they are buzzwords, and I'm sure that in the previous speakers, they have already given you enough idea how these big data are. And in case of big data analysis, the linear algebra plays really an important role. So this nowadays this for this big data boom, linear algebra is nowadays very important in our day-to-day life. So let us try to have a discussion about how we are basically using the data. So it's a little old data. It's a data from 2019. It says that Google processes over 5 exabyte of data per day. So 1 exabyte means 10 to the power 9 GB. Can you believe? So Google processes 5 into 10 to the power 9 GB per day, and that too in 2019. Within this lockdown period, I don't have the statistics with me currently, but I am searching for that. The similar data will be much bigger So it's much more fold than what we had in 2019. So Google handles 1.2 trillion searches every year. 1 trillion means 10 to the power 12. Facebook generates 4 petabyte of new data per day. 1 petabyte means 10 to the power 6 GB, huge. 4 into 10 to the power 6 GB data per day. 350 million photos are uploaded per day. Users generate 4 million likes every minute. So now you can understand how big. WhatsApp also 500 million user. It possesses more than 70 million messages a second. 70 million messages a second. Now you can understand how much big data that we are dealing with, and as a result, we are actually dealing with big data, and of course, the security or how should we deal with the big data, or what are the inferences, or what are the information that are stored within that big data is a challenging question. So for business analytics, you can understand that you have too much data of lots of customers, and from there you want to extract the most important data or most important information that will be helpful to expand your business, or just that will be more profitable for you, that you are actually trying to find. So what kind of questions that you are asking is very important in case of big data. At the same time, while dealing with lots of data, the security aspect is also very important, because suppose you are many, I mean, your many information like your name, date of birth, and all, along with your biometrical data, are also stored inside your this Aadhaar card. So so you can understand the population of India, those who are having this Aadhaar card. So huge amount of data is stored in some place, or maybe distributed in some places, and the security of all those data is very important. So as a result, cybersecurity plays an important role. At the same time, when we talk about the communication, for example, suppose we are having the cable channels, or we are having the mobile phones, the wireless communication. Not only that, from satellite we get a lot of images, say for example moon or maybe Mars image. So we'll get a lot of images, and when the signal comes from a satellite through the atmosphere, the signal got distorted by means of some, say, nature, or some ultraviolet ray or something. Then when we receive that distorted data by using linear algebra, so basically that by using some linear code, or by using some error correcting code, we sometimes remove all the distortion that already had been happened with that data. That means if some error happened within some limit, then that data can be this error can be removed from the data to get the original data. That's why we get the almost original image that are usually sent from the satellite by using linear algebra, mostly some error correcting techniques, and the linear codes are basically nothing but the elements of a vector space. So in case of a linear algebra, and the coding theoretic techniques are very much correlated. That's why linear algebra plays an important role there also. So as I mentioned, cybersecurity plays an important role, and in my talk, I will basically talk mostly on cybersecurity and a glimpse how linear algebra could be useful into our day-to-day life. So as I mentioned, a huge amount of data usually we every day we deal with. So lots of activities we do usually with this very big data. For example, we check our email, we download things, we chat with somebody, we play online, we buy something, we see news using our YouTube or direct telecast, etc. So many of the days, I mean, whole of the days, we stay busy with lots of data. And as you understand that in all these applications, you need to put some password. So now you will have plenty of passwords. And the best thing is that if you can remember all the passwords, so that that can be stored at your brain. But there are some passwords which are very big. For example, when Google they store, so if you pay some money to Google to protect your data, usually all the data with all the service that usually Google provides us are free, but sometimes if you have more data, then you need to pay some money to Google, and it says that it's taken from the Google website itself. It says that if they are protecting your data, then so suppose this is your whole data, then it's actually get into they make it pieces, and each of the pieces are being encrypted by some key. Okay, and then these encrypted data are being stored separately. Now what it says that each of these keys, so these keys are called key encryption key, and all these key encryptions key again then being encrypted by another key, and that is done by Google's Key Management Service, so KMS. So that means once you had a key, and then all these keys are being again encrypted by another key, and that particular key is being stored by using this Google's Key Management System. Now you can understand that these big keys, I mean, they are all automated keys. Nobody is there to find your keys or to make your keys. So everything is being done automatically. And according to Google, all these keys are distinct, even if they are coming from a same piece of information. They are all distinct. That means huge amount of keys they need to store as a result, and the size of these keys are very big. For example, they use for key management scheme, they use AES 256 or RSA or something elliptic curve crypto system, and they require the keys like this. So each of the keys might be of this size or even bigger than this. So you can understand that nobody can remember these big numbers. Okay, so you have to store somewhere. So if you are going to store somewhere, then if that is being stored or that is being attacked or that is being hijacked or that is being distorted, then you can understand you will be nowhere. That's why you have to make a copy of the same thing at different places. Now you can very easily understand that if you make a copy of the same thing and place it differently at different places, then the probability of losing the data is more. So you need to make some extra things so that this data can be stored properly. So data storing is an important aspect for not only for you, but also for big giant like Google, Microsoft, everywhere. The securing data is an important issue. So in this talk, I will try to explain few of these techniques, but since I will not give you much more mathematical details on this, just give a kind of hints or give certain concepts how they are being done, so that you will get at least some idea at the end of the day. So the question is how these keys can be stored securely. Okay. For that, in cryptography, we use a special kind of technique known as secret sharing. So let me first try to explain what is secret sharing. Suppose we have three friends, they are very good looking, and these three friends, they want to, from their dresses, it's quite clear that what could be their profession, and they decide that whatever income they will have, they will put all their income inside a box. But since they are very honest, they don't have belief on each other. So one friend don't believe other friend. So whatever they decide that, so they will put all their income inside the box, and they will keep a lock and key. And this lock and key should be such that to open that lock, at least two friends should be present. That means for a single friend, it should not be possible to open the key or open the lock, but there should be at least two friends. If all the three friends are agree to open the lock, it should be fine, but it should be at least two friends should be present to open that lock. That means the normal lock and key will not be sufficient. A special person, in cryptographic term we call him as dealer, who will be present, who will basically give each of these participants some of the keys, and if at least two of them they will present to open, they can open the lock, and for a single friend it should not be possible to open the lock. After giving this lock and key, the dealer will disappear, and each of the friends will operate on their own. So this kind of scheme, in cryptographic sense, we call them threshold secret sharing scheme. So here it says that T and W be two positive integers such that T less than equal to W. A TW threshold scheme is a method of sharing a key K among a set of W participants. W participant, in my example, the W was 3, in such a way that any T participant can compute the value of K. That means any 2 or more participant can compute the value of K, but no group of T minus 1 participant can do so. So T minus 1 means, in my case, T was 2, that means one participant cannot be able to compute the value of K. So here computing the value of K means they are able to open the locker. So that's the idea of threshold scheme. So those who have the idea of going to the bank locker, they might have seen this kind of concepts where there are two keys for a bank locker. One key is with the customer and another key is with the bank manager or somebody else from the bank. If both those two keys are being joined and both the keys are operated simultaneously, then only the bank locker opens. That means it should not be possible for the bank manager to open the bank locker alone. Similarly, it should not also be possible for a particular customer to open his bank locker without the help of the bank manager or somebody from the bank. So that's why this is a 2-2 scheme. That means the locker is being distributed over two participants in such a way, if both of them they agree to open, then only the locker should be opened. Similarly, when we launch some missile, suppose in some country they have a very powerful missile at their hand, so the control of the missile is not given to a particular person, because if somebody wants to launch the missile at any time, then it could be a disaster. That's why the control of the missile is being given among a set of participants, for example, say general, maybe the prime minister, then the defense minister. If at least say 2 or 3 of them they agree to launch the missile, then only the missile could be launched. That means it should not be possible for some forbidden set of participants, those who are not qualified to launch the missile. For them it should not be possible to launch the missile. So that's the idea. Similar kind of idea you might have seen when you have the new credit card or debit card at your hand. So it comes through post, right? So nowadays it's not happening, but say at least 2 years back, it happened that the PIN of that credit card or debit card, the PIN usually doesn't come with the original card. The PIN comes after a few days of coming the physical appearance of this original card. That means the card and the PIN are not coming to you simultaneously. Similarly, when we buy something online, so we have to give all the details about this credit card or debit card. And sometimes you also have to make the OTP. And OTP comes to your registered mobile. That means it's a kind of binding. It's a kind of authentication that you are doing. So it's not like you buy something by using only credit card insertion of your credit card number. It also distributes the whole thing among your laptop as well as your mobile, your registered SIM, etc. That means the whole thing is being distributed among few more devices, or few more authentications are required for getting your money or buying something using online transaction. So let us try to now see how this can be done, or how this can be achieved. Okay, till now, anybody has any question? If you have any question till now, you are free to ask me. Okay, any question till now? You can unmute yourself and ask me the question if you have any. Okay, so if not, then I will go to construction of some scheme. Right. Okay. So suppose I want to construct a 2-2 scheme, and Japan is my password, and suppose he is the dealer. This dealer wants to give the password among these two participants in such a way, if both of them they will come, they will get the password back, but it should not be possible for one to get the password. Okay. So a simple way could be the dealer has given Jap to this guy, this girl, and to this boy. If both of them they will come, they will get Japan and they will get the password. But if you think a little deeply, then you will understand that this scheme is not a very good scheme. Why? Because if this girl comes to know that all the password alphabets are in capital and this boy will give two letters after her, then what she can do, she can guess the last two alphabets, and she knows that the number of choices could be 26 square many, because she has to get only two of the places, and for each place the number of options is 26, so there will be only 26 square many such options she has to guess. Similarly, for that boy it will be 26 cube many options. Okay, so the point is, if for the girl, if you look at the girl, the information that the girl has is basically 60% of the password. And for the boy, he possesses 40% information about the password. So we consider this kind of schemes as not a very good scheme, because in both cases, the boy and the girl, they knows the amount of information they have are significant. So we want a scheme in which this should not happen. Let us try to have a look at this kind of scheme. Okay, let me open up Paint. Okay, till now, any question? If you have, please let me know. Okay, so okay, so suppose I want to have a better scheme. Suppose here my password is this 011010, and the dealer wants to distribute the same like the previous case, something to this girl, something to this boy. Now what the dealer will do, suppose the dealer has some unbiased coin. So what do you mean by unbiased coin? The probability of getting head and getting tail is exactly half. Suppose you toss the coin, and then the probability of getting head and the probability of getting tail is exactly half. That is known as unbiased coin. So if we have much more time, then we can discuss a very nice game with this random event and all. But at this point of time, I'm not going to that. Suppose this dealer has some random choice, and suppose the dealer has decided if he gets head, he will put 1, and if he has tail, he will put 0 on a string, on a paper. So what he does, he first have a look at how many bits are there in this password. So it's 6-bit password. So what he does, he makes a coin toss for 6 times. So consecutively, he makes a coin toss for 6 times. As a result, what he will get? He will get some strings of heads and tails, and he can convert these heads and tails into zeros and ones by this rule. If he gets head, he put 1. If he gets tail, he will put 0. As a result, after tossing the coin for 6 times, he will get a sequence of zeros and ones. Suppose this is his sequence of zeros and ones. Okay. Now you can understand that this is a random sequence of zeros and ones, because the probability of getting 1 and 0 are exactly half. Okay. Now he gives this random string to this girl. Now you can understand that, okay, since this is a random string, from this string, the guessing about this secret is really difficult. Because why difficult? Because it's a random string and there is no relation between this secret as well as this random string, except for the length. Okay. Now what to give to this boy? Now what he does this part. So this is the secret and this is the random string. What he does, he makes an XOR operation. So for mathematicians, for engineers, XOR operation is quite well known. It's a Boolean operation like Boolean AND and OR. For mathematician, it's also very easy. It's nothing but addition modulo 2. That means if you have both say 1 1, that means it should be 0. If you it's 2 and in modulo 2 this value is 0. So 0 1 it gives you 1, 1 0 it gives you 1, and it will be 0 again if both of them are 0. So that's the truth table for XOR operation. Okay. So for engineers, XOR is like this, and for mathematician it's nothing but addition modulo 2 bitwise. That's all. So what he does addition modulo 2 or XOR operation bitwise among this. So this was the secret and this was the random string generated as an outcome of the 6 times coin tossing process, and whatever he gets make a XOR operation and he gives it to him. Like see here 0 1 means 1, modulo 1 is 1, 1 1 here the value is 2, modulo 2 is 0, 0 0 is 0, 1 0 is 1, 1 1 is 0, and 0 0 is 0. So he gets this. Now you can understand as okay, this is a random string. So for this girl, it may be very difficult to guess about this. Now this is, you may think that okay, this may not be a random string because the secret was involved and then it was odd with a random string. Then there might be some extra information inside this. So let us try to analyze that, what is happening. So here I have one coin tossing event. So suppose say probability of, suppose this is getting coin tossing, say t equal to 0 means t equal to, okay, it's t is already there, so maybe coin tossing I can say like c equal to coin tossing event say equal to 0, that means getting head equal to same as probability c equal to 1, that means coin tossing event is head is basically half, that is already given. So here it was a secret and there must be some distribution on the secret. So suppose s is my secret random variable, suppose s to be 0, suppose is the probability of s to be 0 is p, and suppose then the probability of s to be 1, because it's a binary string, so it must be 1 minus p. Now I am trying to calculate what is the probability when the secret s is XORed with the coin tossing event c. So what is the probability the secret XORed with this c? Okay, what is the, when this will be 0, what is the probability that secret and this coin tossing event, that is the random event, when you are making it a XOR, what would be the probability that this is 0? Now when it would be 0? When both the secret and the coin is, both of them are 0, both of them are 0, or both of them are 1. Okay, that means probability of s to be 0 and probability c to be 0, or that means plus probability s to be 1 and probability c to be 1. Now what is that probability? S to be 0 is p, so p and c to be 0 is half, plus probability s to be 1 is 1 minus p, and c to be 0 is, c to be 1 is half. Now if I take a half common, what I'll get? I'll get p plus 1 minus p, and that is nothing but half. Now what it gives actually, it says that if you have a random sequence, this is the random sequence, if you make XOR with some having any probability distribution, after making it a XOR, the probability of 0 to be half. That means after making XOR with C, which is a random, that whole thing becomes random. Because why? Because the probability is C to be 1 is also half, because they are binary. So if 0 is half, then 1 has to be half. That means they are basically random. That means after making a XOR with this random string, that is also become half. As a result, this guy will have no extra information. That means suppose he has this and he wants to guess what could be the value of 0. Because this is a random event, so from here he will not have any guess about what would be this value. Okay, So this boy will not have any extra information about the secret. Similarly, this girl has no extra information about the secret. Now suppose you are a third person, you are outsider. Now no information means suppose he has this bit, he wants to guess what is this bit. As I mentioned, the probability of guessing this is basically half. Now if I ask you the question, you being a third person, you do not have any share. So we call it as a share. You do not have any share. Now I want to ask you the question that what could be the probability of this bit to be half, to be zero, because you have only two options, either it could be 0 or 1. So the probability of guessing it correctly is exactly half. Similarly, for this boy, even if he has the share with him, the probability of guessing this correctly is also half, because it's a random string and it was again a random string. So probability, if she has this, he knows this last bit and she wants to guess the last bit of the secret, the probability of guessing it correctly for her or for him is also half, like you who are outside the participant range. So you don't have any share, but still the probability of guessing it correctly is exactly same as this boy and girl who do have the shares with them. That means both this girl and the boy alone will not have any extra information about the secret except the length and the binary nature of the secret, like you. But when they come together and when they are going to make an XOR operation about these two shares, they will get back this secret. That's why this kind of schemes are known as perfectly secure secret sharing scheme. So in this class, I'll just going to give you a very simple technique of constructing this kind of scheme, but it's quite interesting. It will be done visually. That means in every cryptographic scheme, you have to calculate things while you are getting back the secret. But here I'm going to give you an example where you don't have to do anything. No calculation is required. Only a visual thing is sufficient for you to get back. Okay, just I ask some of you for a voluntary. Can you please write your name in the chat box? Whose name will come first? I will take that name for my experiment. Only that name, not him or her. So could you please type your name on the chat box? Okay, Rita. Okay, thank you. So suppose my secret is, so here the secret is Inria, and here my secret will be Rita. So let us try to find how it will be done. Okay. So here I'll just type Rita. Okay. So Rita is my secret password. Okay. I will cut it. Okay. I'll just save it. I'll save it as secret image. Save it by this. And now I'm going to write I'm just going to run a Python program. Yes. So it will generate few of the shares. Just a minute. It has already, I think it has already generated the shares. Yes, so Rita was my secret and it has generated 3 of the shares. So what is happening here? So this Rita is my password and I want to distribute this password, or I want to distribute say among 3 participants in such a way that they are going to, each of this is my share. So let me just show you how the shares look like. So here is my share. So insert image, upload. I'll upload it from machine. So this is my share 1, and let me put another share image. So this is my share 2. Okay. Now these are my 2 shares, and these shares the dealer will give this share printing on transparent paper. You know what is the transparent sheets? So the dealer will print these shares, these random looking images on two transparent sheets. Okay. Now let me check what is happening. Now, when one transparent sheet is superimposed over other, that will give the Rita back. What is happening here? So here we have two shares, two transparent sheets. You can see two transparent sheets. Now, if I superimpose one transparent sheet over other, you can see that this is the more blacker portion. If I increase that, it will look more blacker. If I increase that, this will look. And if I superimpose one after another properly, not even superimposed properly, not even superimposed. So let me superimpose properly. Yes, when they are superimposed one after another properly, then you will get the password. Then you can understand the name Rita came back. But if you just distort it a little bit, you will find that it vanishes. It vanishes. It requires a steady hand to just put one after another. So that is the very interesting idea. So this is known as visual cryptography because it's completely done visually. So you don't have to calculate anything. You just need to superimpose one transparent sheet over other properly. And when you superimpose properly, then you get back the information. And it should not be possible that I need to prove mathematically that from one transparent sheet, you should not get any information about Rita. So that's quite important. So that's why this is known as visual cryptography because it's done completely through visual system. Okay, so here the password was INRIA, and when these two transparent sheets they are printed, the shares are being printed on two transparent sheets. When they are superimposed, you get the INRIA back. So the question is, how did I make this, or what is the mathematics behind that? So they are based on this of our papers. Okay, so let me quickly do it on the, not here, maybe on yes, here. Okay, let us try to explain the whole thing. Okay, so as you understand that the picture was a black and white image, so it was a black and white image. So as you know that in black and white image you will have some pixels. So pixels are either black or white. So you know nowadays you all use this my pixel, my camera is that megapixel, my camera is that megapixel, etc. So if it's a completely black and white image, then this image is basically made up of, suppose this is a black and white image. So this black and white image is basically made up of, if you zoom it in computer, if you zoom it, then you will find that each of this small part of the image is basically made up of small boxes. So each box is either black or white. So if you zoom, say, this part of image, you will find that this image is basically made up of few boxes, and this box is either completely black or white, completely white. So each of these boxes, small boxes, are known as pixels. Okay. So these pixels are the ingredients or the building blocks of this image. Now, how to use this concept? So my aim is to construct a 2-2 scheme. But before that, let us try to have a look at the basic mathematics behind it. Okay. So here, what we are going to do, so if I ask you the question, have you ever taken your printout, this black and white printout? Suppose you have a purely black and white printout, not a color printer. Suppose you have a black and white printers, and have you ever taken any of the printout on a black paper? If I ask you the question, have you ever taken the printout on a black paper? So usually we take the printout on a white paper. So why we usually do not take the printout on a black paper? Anybody? Can anybody give me some answer? Why why it's not the case? Why we do not take the printout on a white page, on a black page? Anybody? Anybody? Yes, please unmute yourself. Yeah.
No, so someone wrote it, sir. I was just going to say that since the picture itself is in black.
Yes. So since the picture is itself in a black, so of course in a black and white, when we take a printout, the ink is black and it's purely black. So if the image has some part in white, for example, suppose my image is like this in a white portion, suppose my image is this part is completely black and I have a circle, complete circle, which is completely white. And if I take a printout of that, what ink the printer will eject here? So the printer is not going to eject anything if it is white. The printer will eject the black ink or the black point only when it's a black. Okay. That's why if you take this on a black and white paper, then suddenly it will be completely black because that part was default black and outside will also be black due to the ejection of the ink. So you will not be able to distinguish if it's I mean you may able to distinguish, but mostly you cannot see it. That's why the contrast is very less, because the black and white contrast will be very less. That's why we do not take anything, any print for black and white. We usually take in the on the white page. Okay, so what is actually happening? So if I have a black pixel and if I print it on a transparent sheet, and if I have a white pixel, so what is the meaning of white pixel on a transparent sheet? That means the printer did not eject any ink here. That means it's basically the original transparent sheet. Nothing is ejected. That's why we call it white. And why this is black? Because the printer already ejected black ink onto it. Okay, that's why it's black. When we are going to superimpose one after another, suppose this is a black pixel or the black part printed on a transparent sheet, and this is the white part printed on a transparent sheet. That means nothing is printed on it. Now, if I superimpose one after another, as an effect, what color should we see? Anybody? What would be the color that we should see? Anybody? Yeah, please unmute yourself. Yes, so somebody has already written. It should be the black. Yes, perfect. So if we have, say, here white and here black, what color should we see? Here also we'll see black. Now, if we have both black, then also we see black. And if both of them are white, that means transparent, then as an effect, we'll suddenly see the transparent effect of this. Now, do this superimposition operation remind something from your Boolean algebra? Anything that you remember from your Boolean algebra? Any operation that you think of?
Sir, idempotency.
Idempotency, okay, a square equal to a you are talking about. Any operation. I'm not talking about this property, but I'm talking about some binary operation that you think of.
Or
yes, in Boolean ring, the idempotency is preserved. That's good. But I am looking for some binary operation. Any binary operation that you may think of? So binary operation, binary composition. What are the binary compositions that you are taught in your Boolean algebra course?
Random.
or operation.
Okay. Or operation. Somebody said me or operation. And somebody told or. And I must say that both of them are correct. Depends how you're encoding. If you write black for 1 and white for 0, then what you're getting? So this is 0, 1, 1, 1, 1, 1, and 0, 0, 0. Now, can you guess what is this operation? This is binary. 1, 0 gives you 1. So this is binary OR operation. Very good. Now you just replace it by other way around, if I replace it by, say, this is by 0 and this is by 1, then what you are getting? You are getting 1, this is 1, this is 0, you are getting 0, sorry, it is 0, this is getting 0, this is 0, you are getting 0, 1, 1, 1. Now tell me, what is that? 0, 1 gives you 0, 1, 0 gives you 0, 0, 0 gives you 0, 1, 1 gives you 1. Then what would be the operation? AND.
This should be AND.
Okay. So it depends. If you represent black by 1 and white by 0, then it would be your binary OR operation. That means the physical superimposition operation is nothing but your binary OR operation. That's very interesting. So that's here the application of mathematics lies here. See, we do many physical operations, many physical things without knowing the behind the mathematics is. What is the mathematics behind? Here is a very interesting example where the simple Boolean OR operation or AND operation could be interpreted nicely when you are going to superimpose something. Okay. So now we are in mathematics. So now I am going to explain you how this scheme can be constructed. So I want to construct the 2-2 visual cryptographic scheme. We call it VCS. Okay. So suppose, so what is the aim? So the dealer has two participants, and the idea is if both of them they will join, then only the image should be recovered. Okay. So how this can be done? So the dealer must have some algorithm to do so. So the dealer is basically trying to give the algorithm for two pixels. One is for black pixel and another is for white pixel. Now, if we can do so for black pixel and white pixel, then he can apply this algorithm to whole image, because I know that my secret image is either black image or white image. I mean, the pixel of each pixel must be either white pixel or black pixel. So if I have some algorithm for black pixel and white pixel, then we are basically done. We shall apply the everything on this image, because I know that this image must be made up of small pixels, and I'll check what is the first pixel. If it is a black pixel, I'll come here and I will do the application. So what he does for black pixel, in each of this transparent sheets, so there are two transparent sheets, right? So transparent sheet 1 and transparent sheet 2. That means this is for participant 1, this is for participant 2. For the first transparent sheet, he prints one black, one white. For the second transparent sheet, he prints one white, one black. Now, if you are going to superimpose one after another properly, then as an effect, what you will see? You will see two black, because this over this will give you black and this over this will give you black. So as an effect, you will get two black pixels. The same thing could also be done by using this. So this is white and then black. Then what should be this? This is first black and then white. If you are going to superimpose them, you will also get two black pixels. Okay. Now for white, what happens? For white, he has two options. First white and then maybe two black. And here also he gives one white, one black. When they are going to superimpose, they will get one white, one black. Now this thing may also be done using this one black and white. So here also one black, one white. When they are going to superimpose, they will get one black, one white. Now I'm telling that this is the algorithm. Now let me explain how this algorithm works. So you can understand that for black pixel, he has two options. This option or this option. For white pixel also, he has two options, one option or this option. So he will make a coin toss here. If he gets head, he will take this path. If he gets tail, he will get this path. Similarly here, if he gets head, he will take this path. If he has tail, he will take this path. So what is the algorithm now? the dealer will check the first pixel of the secret image. If the first pixel is a white pixel, he will come here and make a coin toss. Suppose he gets tail. Then what he will do, he will print this part to the first transparent sheet and this part to the second transparent sheet. So when you superimpose one after another, you will get basically one black, one white. Suppose the second pixel is a black pixel. Suppose this is a black pixel. He comes here, he will again make a coin toss. Suppose he gets tail, head. So he will print these two pixels just beside the pixel that he already printed on the first transparent sheet, and on the second transparent sheet he will put another, and so on. So that's the algorithm. For each pixel he will do the coin tossing. So this is a random event. Now what I need to show you, that if both of them will come together, then for black he is getting 2 black pixel, whereas when two of them will come, they will get, for white they will get 1 black and 1 white. But still here the black portion is more, but here the white portion is, black portion is less. That's why there will be a contrast difference, and our visual system is very strong. That's why we can distinguish this. See, you can see that the background of this image was completely white, but here the background of the image is not complete white. It's a gray, but still you can distinguish. For black one, this is more black, and for white, which was the background of this INRIA, was now become gray because it has less black compared to the black portion here. That's why the visual system can visually recover these two contrast, and they can get it back to you, and so you get this scheme. Now what I need to show, that suppose one participant, they came and they want to guess whether it comes from black or white. Suppose one participant has this share and he wants to guess whether it comes from white or black. So it comes really from black, but you see that the same pattern is also present here. That means out of these 4 patterns, 2 patterns are of the same type. That means the probability of guessing it correctly is exactly 2 by 4, that means half. Now think about yourself. You do not have any share. You know that the pixel is either black or white. Now what is the probability of guessing it correctly? For you also, it is exactly the half. As a result, the probability with which the participant having a share will guess it correctly is half, is same as the probability that you, being the third person who do not even have a share, will guess it correctly with the probability exactly same as this guy. That means this guy will not have any extra advantage having only one share. But if both the shares will join, then only both of them will get the knowledge that you do not have as a third person, but both of them, they will able to get the original image back. But for a single participant, it should not be possible to get the secret back. That's why this is known as perfectly secure secret sharing scheme, and that's visual cryptographic schemes. And many of such schemes can be generated, and for engineers it's very easy to implement. You can use C or Python code to implement this. I have implemented is using Python, and many researchers are going on, and lots of linear algebra can also be used very easily here to get nicer schemes. I'm not going to details about all those schemes. Rather, I will wait for a few questions or queries if you have. Then, but before that, I must acknowledge Google for providing me nice images, and my scholars, and of course my project, the government support from Department of Information Technology, Government of India, DRDO and YZ from Ministry of Defense, DST Serve, DST Matrices, DST FIST, NBHM. So there's 2 Japanese projects, JSPS and JST from Government of Japan, for providing me supports to perform all the research work that usually I do. So if you have any question or comments, you are free to ask me, or you can send me email to this ID. So visual thank you to all of you.
Any question? If not,
So if you have any question, you can directly
is
ask
there?
me.
অভিষেক বাবু আপনার ইয়েটা চ্যাট বক্সে দিয়ে দিতে পারেন মেলটা যদি কোনো কোশ্চেন টোশ্চেন থাকে ওরা
আচ্ছা আচ্ছা so you can send me my university ID
ওরা তাহলে হ্যাঁ ইউনিভার্সিটি আইডি ওখান থেকে ওরা কোশ্চেন করতে পারে anyway if there is no question then thank you Professor Adhikari for this.
Just one thing, if you are interested in this basic number theory courses and all, so you can search my name in Google. I have a YouTube channel where this year I have taken courses at Residency University for this undergraduate level students to explain the basic number theory and its application to cryptography with in details. So now I am teaching them the graph theory, and for if you are in a higher level, then I am teaching now this ring theory course with applications. Of course, I like to show few applications in real life, so that you can also have a look at that. So systematically, all the things are given there. So if you are interested, you can have a look at this things. Okay, thank you.
Thank you. Thank you, Professor Adhikari, for this wonderful derivation. And the valuable talk you have given that reflecting your in-depth knowledge in the subject, which has widely encouraged us and enriched us as well. Thank you very much. One or two things before the last part, a vote of thanks. I want to mention one or two things. I have already said you about the feedback form. You see, it is already the feedback form link for the feedback form is given under Dr. Ajoy Sen in chat box. You get the link. There are two entries actually. You see, for the under Ajoy Sen, Dr. Ajoy Sen. So, but the first one is not. Second one, it is written over there at 1:17 p.m. That is the feedback form given in the chat box. So you just go through that link and please fill up the feedback form for helping us for preparing your e-certificate. Number one. Number two, I am asking Mr. Kushal Sen. He may upload some link for you. If you have any question, any queries about big data, anything, then Mr. Sen can answer you through that link. So I just give me 1 second. I may ask Kushal. Just a minute. I may ask Kushal to upload his link. Hello, Kushal. Are you online? Are you present, Kushal? Hello. Mr. Kushal Sen, are you here? Are you present? by this time, may I request Dr. Panchali Mujumdar for Dr. Panchali Mujumdar is coordinator of IQAC of East Calcutta Girls College for delivering the vote of thanks. By this time, I will contact Kushal and tell him to upload his link. And হ্যাঁ আপনি জয় করেছেন?
Am I audible? আমার শোনা যাচ্ছে?
হ্যাঁ 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 আচ্ছা এক সেকেন্ড আমি একটু আরেকবার একটু বলে দিই please remember to fill up the feedback form. It is given in chat box by Dr. Ajay Sen. The second entry, you take the second entry, you follow the time 1:17 p.m. The link is given, the feedback form link. You just fill up the feedback form, please. Now Dr. Panchali Mujumdar will deliver the vote of thanks. Hi, এবার আপনি বলুন।
হ্যাঁ, thank you Jayanta Babu for introducing me. Okay. Thanks for.
And Dr. Panchali Mujumdar is coordinator of IQAC of East Calcutta Girls College and very active. She is.
No. We all work here as a team, and all the teachers and non-teaching staff of our colleges, all of them are actively participated in every sort of activities that are conducted by our institution. And today we have the opportunity to conduct this sort of webinar so that we can reach the farthest corner of the society, including the education that started from the school level to up to the higher education. And here today we have the college students with us. Previously in the webinars there were a lot of number of school students who were actively participated in the ISI workshop. And first of all, in the vote of thanks, I want to convey on behalf of East Calcutta Girls College our regards to Professor Dimal Kumar Roy, whose initiative has made it possible. On behalf of East Calcutta Girls College, we also convey our regards to Professor Bashut Chaudhary, Vice Chancellor, West Bengal State University, who, apart from his busy schedule as an active going on in university, he has attended the webinar and encouraged us a lot to continue the journey. Professor Dimal sir has always put a light on the pathways for the students, particularly the young ones who will host the flag of the nation in future. We are the privileged one to have him with us. Here we have with us our respected Principal Madam, Dr. Shukla Hajra, without whose active encouragement or active participation we can't proceed one step in our institution. She always encourages us to do the things that will be helpful for the benefit of the society. And on behalf of East Calcutta Girls College, we all the teachers, the non-teaching staff and the students, we have the opportunity, or we are the privileged one to have her with us. Thank you, madam. Thanks a lot. I'd like to convey our regards and thanks to Professor Shubhamoy Moitro, Professor Pinak Panipal from ISI, Mr. Kushal Sen from Microsoft Corporation, Professor Abhishek Odhikari from Presidency University, who have delivered their lectures in these webinars. And I think the students are they are very much benefited by this webinar, which shows a pathway for them. At last, I want to thank Dr. Ajoy Sen, the teacher, head of the Department of Mathematics at Calcutta Girls College, for conducting this webinar. And lastly, I want to thank Professor Jayanto Ghosh, without whose cooperation, without whose help, we can't do this sort of program. So, thanks to Jayanto Babu also for every cooperation and help. He always is with us, with his Calcutta Girls College, and giving every effort to success all these sort of webinars. We hope that in the future we also have him with us. So thank you, Jayanto Babu, so much for conducting, for your nice, you have nicely conducted this webinar. Thank you so much. Thanks to all the participants who have participated in this webinar, all the students, today's participants and the students who have participated a lot in the previous webinars also, on behalf of this Calcutta Girls College, without whose active participation, all these webinars are meaningless. So, thank you so much. Thank you, Jayanto Babu. Jayanto Babu? Jayanto Babu, can you hear me? Hello?
Thank you. Thank you very much, Dr. Mujumdar. Lastly, probably Kushal Sen has joined. Kushal has joined.
Yes, I am here. Hi, everyone.
Okay, you please upload your
Yeah.
link in in the chat box.
Right. So I'm going to
So
share
that participants, if
the.
they are interested, they can ask questions and some interactions, may do some interactions with you.
Yeah, sure. So I'm going
And
to
once again,
share yes.
In chat box you can give the link. And once again, I want to mention for filling up the feedback form by the participants, so that we can send them the e-certificate. আর কুশল বাবু আপনি একটু করে দিন এটা তাহলে।
I have shared the Q&A link and the link to the slide, so you can access the slide over there. And the Q&A link is for any questions that you may have after you go through the documents, or we have it right now. So just share your doubts or whatever questions you have regarding any of the topic discussed in the Q&A link regarding the big data, and we'll be happy to respond to them. We'll have to be individually answering to each one of them. So thank you, everyone, and thanks to Sir for organizing this.
Okay, and Abhishek Babu also has given his link so that any participant can interact with him. So both Abhishek Babu and Kushal Babu has given. So thank you very much for joining this session and this webinar. I think everyone enjoyed it. Thank you very much. So we can stop over here, and please fill up the feedback form. Okay. অজয় কি আছেন? অজয় সেন, অজয় কি কানেক্টেড?
হ্যাঁ, তাহলে আজকে এন্ড করছি এখানে, তাহলে রেকর্ডিং আমি অফ করছি।
হ্যাঁ, ওরা ওই ফর্মটা যদি ফিল আপ করে, এটা বোধহয় একটুখানি সময় খোলা থাক নাকি
ঠিক আছে, কোনো কোনো অসুবিধা নেই, তাহলে খোলা
ফিল আপ করার জন্য।
ঠিক আছে, 10-15 মিনিট খোলা থাক,
সাউন্ডগুলো
15
অফ
মিনিট।
করা থাক।
হুম,
হ্যাঁ, 10-15 মিনিট বরং খোলা থাক। ফর্ম, ফিডব্যাক ফর্মগুলো যারা যারা করার করে দিক। হ্যাঁ, সাউন্ডটা অফ করে খোলা থাক।
ঠিক আছে, ওকে।